So welcome to class. For those that have not joined yet, you can always reach out to them, welcome them to class, tell them about class. I believe that some of you guys have made friends, right, during the course of the mentorship. So reach out to them, talk to them, tell them that the class has started. So today we are going to be considering two things, and you're going to have two mentors teaching. I will be the first mentor, and the second mentor would be Ibrahim Idris, which is going to be taking you on introduction to SOC, which is Security Operations Center, or SOC, depending on what you know it to be. And I will be taking you on operating systems for security. So it's going to be a mixed class. I would probably try to take a few demo to just practice some things for you. And I believe that prior to now in the morning, your course rep, with the help of the, community manager for the mentorship, has relayed or passed the message across to the group. And they mentioned that you guys should watch three videos on YouTube. The first one has to do with setting up VirtualBox. The second one has to do with setting up Kali Linux in VirtualBox. So, I mean, the three videos, I think that should be lesson 49 to 51. Those three videos are talking about, or they were addressing the installation or the setting up of Kali. That's just the summary of everything, right? So, I will be sharing my screen now so that we can both be on the same page. One second. Um, so I'm starting my Kali because I want that to be working by the side as we are going to be working on we are going to be working on a demo together, as I mentioned earlier, right? So at the end of the day, we are going to give you a class note as well. We got a concern about class notes because your course rep sends some questions to us. I think I would just use I would use this medium to quickly address the admin side of things. So send some questions to us. Number one, about whether this particular mentorship is meant for intermediate and intermediate or beginners. And if you're looking at the trend of things, you see that it is meant for both, right? There's a PCAP file I should share with you for the last assignment. I've not shared it. Sorry, I've been a little bit occupied. I should have. I was trying to build up the cap file today, which is the capture file for the Wi-Fi that you guys are going to analyze, for the Wi-Fi file that are going to analyze. I'm building it up today, but I didn't eventually finish the process, right? So, but it should be ready latest by tomorrow. So we are going to share it with you, and you can run your analysis with us, with it. So that will be for that. So then talking about whether it's meant for intermediate or it's meant for people who are just starting in cybersecurity, you can see that it's meant for the two. If you consider things very well, or if you check things very well, you see it's meant for the two. Because I'm not sure there is any school anywhere in the world where you are going to take a class, and in the first class about cybersecurity, something you are new to, and they are going to be telling you that you need to use Wireshark to capture anything, right? And that's why we mentioned it earlier, that aside from the fact that we are coming here to feed you or to teach you, you should be ready to do some learnings yourself. So this 1 month is just like we are compressing like 5 months into one. So it has to be rigorous, right? And that was why I mentioned that if you are doing any other thing that is really tasking, I would probably advise that maybe you push this to like next cohort and join the next one because it's going to be very rigorous. You can see that there's a challenge, there are videos you're watching on YouTube, there are assignments that you're meant to do that and you have to submit. For the challenge, you are submitting the challenge for each day. You yourself, you can see that it's a bit stressful. I saw somebody posting it on one of the groups that I don't know how you guys manage to use your pictures, for the post. I don't know if the person is on this call. He was mentioning that the moment I finished writing my post, I just went to bed because I was so tired already. And that is how it is. That is what we want the mentorship to look like fun, all right, educative, and at the same time, you yourself should feel that you're learning something. You should really feel that you're learning something. So you are not just here for just being here. You are here to really learn. And if you are here to learn, then you should as well feel, then you should really feel that you are learning. So I think that is like the main concern, right? So yeah, that's so I'm going to share a note with you. That's another thing. The second thing I want to address, and I would appeal or talk to other mentors to do the same. So for this class now, I've created a lecture note, which is meant for this mentorship alone. We must not see it outside. So we are creating these notes just for you. So it is meant for this class alone, for this mentorship alone. So I'm going to share the notes with you. Almost everything we are going to be doing are inside the notes. I've broken down a lot of explanations there. So as you're watching the videos, after you're done watching the video, you can come back to the notes and read the note as well. So it's something well explained. Examples are there, different structures are there. So the commands and everything you can run are also there. But I will show you some of the commands. I will give you some as assignments or as an assignment, and I will give you guys a file as well. So when Idris too comes on board, he's going to do a demo with you guys as well, and he's going to give you guys a log file that you guys are going to analyze because he's a SOC guy. So you guys are going to be doing something related to SOC today, but we don't want to really stress you. So I will try and as much as I can to ensure that my own class is not that intense because when he comes on board, he's going to be saying a lot of things that might, be like buzzword to you, or that might sound like jargons in the sense that you might not hear some of those technical terms before. But if you listen very well in this class, I think that will prepare you for what he is going to be teaching. Because SOC is another level of another aspect of cybersecurity. So at that point, you are no longer doing like basics again, like you are entering into something new. And that is how it's going to be subsequently. So we advise you once again that you should brace yourself, all right, fasten your seatbelt and enjoy the ride because it's about to get so interesting, right? So I'll be sharing my screen now and we'll proceed from there. Okay. Um, do I have any question before I proceed? Any questions? Any questions?
Please, if you have a question, you can raise your hand so that we can recognize you as quick as possible. Thank you.
So any questions so far? Okay, someone is saying yes. So if you're saying yes, then raise your hand. Okay, Manuel. So Manuel, I've given you the
So,
mic, so quickly talk. Like you have like 30 seconds.
So
After
please
that,
just
James Chinedu, yeah. All right, go
good,
ahead.
e- good evening, boss. I just wanted to ask if there was a little bit of guidance with respect to this um, the interface we'll be using today for protocols. That's the VBox. I've opened the interface, but I don't know how to proceed to install the Kali Linux and the other things.
Okay. Okay, maybe I can guide you on that as well. A bit. Yeah, maybe before we start this class, probably I can start with that, right? So yeah. Okay, noted, Manuel. But if you watch
Thank
the videos, have you watched those 3 videos?
Yes, I did watch them, but the challenge I had was that upon installation, it launched directly after installation. So, and I got to this page where I had to pick whether basic mode or expert mode, and I had to ask 1 or 2 questions on the group. No response except that.
Okay, so Daniel is raising okay, I think Daniel dropped a message. Daniel Isaiah, you can check the chat section. He said you should reach out to him. So yeah, reach out to him and he's gonna help you. All right. So that means he has set up his own this thing. So let me quickly Manuel, is that all? That's all right. So let's quickly move to Chisimdi. Chisimdi, you can unmute
Good
yourself.
evening, sir. Can you hear me, sir?
Yeah. Yeah, good evening.
Please, I hope there is no problem with Parrot OS. That's what I use majorly for my practicals.
There's no problem. There's no problem. But the thing is, if you get to the ethical hacking aspects, there are some tools that are pre-installed inside Kali. So if you have them in Parrot OS, makes sense. But if you don't, you might just have to set them up. Is that okay?
All right, no problem. Thank you, sir.
All right, yeah, you're welcome. Okay, Kirsten, let me quickly get your question and then we proceed from there. Kirsten, you can unmute yourself now.
Good evening, sir.
Yeah, good evening.
I just wanted to I'm facing challenges. I have a challenge on I've watched all the 3 videos, but there's a part when I think is it the last video. I don't know that part when installing using the command prompt. I was trying to I don't know, but there is a certain part where it's asking for the password and my username. That's where I'm feeling like I have to proceed. After typing is it well, it's something to do with is it cloning? Once it's done cloning, it's asking for my username and the password. Now the password and the username, I'm trying to enter the same one, but it's failing. So I've failed to proceed with the last video.
Okay, are you still referring to the video that has to do with setting up Kali Linux?
Yes.
I can't really remember that part. Maybe I will have to check. So 1 second, let me just try to check what you're talking about.
Um, can I try to check right now before I will just right now the same part I'm talking about so that
Yeah, I
I
mean
don't lay.
that is what I'm trying to check now. To see what you're talking about. 1 second. So hopefully it loads very soon. So I think those are the because I'm seeing a lot of hands now. We have a class to take, right? So others should drop their questions in the chat section so that we don't want to use the entire time to address question and answers, right? So for playlist, we have playlist here, and this is it, right? So that should be 49 to 51. So I want to know the last one, setting up DVWA. Okay. Okay. So for the DVWA, I think you guys shouldn't really
Yeah.
bother on that for now. So yeah, I think that's where the issue is coming from. So focus on 49 and 50 for now. So you don't really bother on DVWA for now because you are not using it right now. Do you get it?
Okay.
So
Yeah,
just
I get it.
focus on 49 and 50. So I think it was because I was seeing Kali and VirtualBox. That was when I added that. So I didn't really say that it was for DVWA. So that one, the DVWA is called the Dem Vulnerable Web Application. It is actually used for ethical hacking or pen testing. If you want to practice things like SQL injection, cross-site scripting, cross-site request forgery, brute force, and many others, right? So you have like vulnerable systems inside that software that you can use to practice, all right? At least you can do that legally without being arrested. So that is what it is meant for. So, but when we get there, you guys are going to see that. So if you have any questions, please, you have Ubuntu machine. Ubuntu can work, most especially for what we want to do today. But when we get to like pen testing and other site, you might want to consider Kali. or you set up whatever tool that is being used in class. Okay, so let's quickly move into today's class and get started properly. Okay, so today, as I mentioned, we are going to be considering operating system for security. And so welcome back, guys. Welcome back to class once again. So before we dive in, here is a quick recap of what we did in the last class. We considered what cybersecurity actually does day to day. We looked at the CIA triad, which involves the confidentiality, integrity, and availability. We considered threats, vulnerabilities, and risk. I think you guys have seen that in the slide deck, even though we couldn't reach there. And for the videos you guys watch on YouTube, I think that video covers for that already. Also, how attackers think, if you check the slide deck, you're going to see that. And today we are going to get our hands dirty a bit. So last class was the map, today is like the terrain. All right, so every attacker and every defender ends up here. They end up in the command line on Linux or Windows, deciding what to type next. And by the end of this session, the black screen with the green text will feel less like a wall and more like more like a workshop. So you're going to see that as we proceed and then try to use our Kali. So now this is what we are going to be covering today, which is our roadmap for today's class. We're going to be covering Linux command line. We're going to be covering Windows plus PowerShell. We're going to be covering users privilege. We're going to be covering Kali Linux as well. Now, what is the importance of this class, or why is it important? So it is important because every breach you are going to ever read about, who is this? Mary something. Is it Mary Judith? Please, you are writing on my screen. I will advise you clean it now, please. I beg you. So you're writing on the screen and it's affecting things. So if there's a way you can clean it up, please clean it up. And I think we need to probably tighten our settings for this thing. They shouldn't be writing on the screen like this. Mary Judith, I'm even trying to see. I don't know if something cleanable. I don't know how Zoom 2 is acting this way, to be honest. So please, nobody should be writing on the screen. Somebody say, I wish I could be able to interact with people like Mr. Victor. I don't know. I don't know what you're trying to say. Maybe you want to interact with me or something. I don't really understand it. But I think what's it called? You guys can always text me. So who is Big Sam? You are writing on the screen again. Yeah, as admin, I should be able to erase it, but I'm not sure. I don't even know how to. I'm not sure I've done something like that before. Okay, I think Sam has been able to clean his own, but the Mary Judith, I've not seen anything from. Let me check. Sorry, guys. I don't know why Zoom is doing all of this. Peter, you want to try your own again? Somebody is trying again. As I'm complaining, people are now trying it. Click on the pencil eraser. Okay, so I'm trying to see it here. Host tools. I will have to look at it after the class because I'm not seeing those features here on my Zoom. But let's proceed, guys, so that doesn't take our time. So, but if this person could clean it up, so Ostus, can you check from your end if you can help clean this thing up? I don't like seeing this thing on my screen.
Okay, let me see if I can.
So I think you can speak with Big Sam. I think he's saying something. And also, we should be able to do our research and disable whatever that is responsible for this. Because
All right.
now this Mary something now has written and she didn't bother to do anything about it again. Okay. So the reason why we are Doing this is because every breach you would ever read about, every ransomware story, every leaked database, every compromised account ended up with someone somewhere typing a command into a terminal. And that means you need to know the command, because if the person trying to attack you knows the command, understand the command, know how to use it, and you that you are securing, you don't know how to use it, then maybe you should go back to the Stone Age. Don't mind me, that's on a lighter note. But you need to understand it, right? You need to be able to use it. So that is just what it is. So also attackers use the shell. And that's one of the importance of this class. Attackers use the shell, like they use they can batch scripts, they can write commands, they can write different commands. They do that to move laterally, within systems or within your network. They move that to create persistence, to persist. They do that to exfiltrate data, right? Also, defenders use the shell. So you as a defender, or maybe as an attacker, but in a legal way now, you need to understand how to use the shell as well. So as a defender, considering the fact that you guys are going to be introduced to SOC today, so SOC is more of blue teaming, so you are defending, right? So as a defender, you are trying to detect, you're trying to contain, and trying to, respond to incidents. And due to that, you need to understand how to write Linux commands as well. Also, same two different intent. Yeah, a bad person, which is an attacker, a malicious attacker, has a bad intent and is using, the same set of commands that you're using. And another person, sorry, a call came in. And another person, 1 second, guys. And another person who is a good person, like who is probably a blue teamer, also has a good intent at heart, right? And just because of that, he is now, he is using like the Linux commands for the good thing. So merely looking at it, you see that we are using the same tool, but with different intents, right? So pretty much that is what we are trying to do here. Um, Now, Linux command line essentials. So that's what we are moving into right now. So why Linux? Please, is there a way we can erase this thing? I don't like the way it is on my screen. It's distracting me. So why Linux? Most of the internet runs on it, right? If you look at the data or the statistics here, most of the public web servers, if you look at the start by operating system, Linux is the one with green. You can see that, that is having about 76%. All right, so blue is Windows, that is 21%, and three are just like running on other operating system. So most of the web servers runs on Linux pretty much. So basically, so that is it. I'm coming. Let me click on this pencil stuff. Um, I think it's only the person that wrote it that can erase it, because I've seen the pencil this thing right now, but I can't see.
Sir, Big Sam, can you stop sharing and share back again? Let's see if it can.
Okay, maybe I should do that. But please, nobody should write on my screen again. Please, I'm begging you. I'm begging you. Nobody should write on my screen again. I'm begging you. It is distracting. And there are people who might want to take screenshots, do things with it. So they'll just be seeing lines all around. It's not good. It's not good. And it is the person who writes on the screen that will be able to erase it. So if you're doing that and we are asking you to erase it and you're not, so it's not that good. Please, I'm begging you. So coming back to the class, most of the internet runs on Linux, right? We can see the statistics for the public web servers. Like we have Linux carrying about 76%, like 21% for Windows and 30% for other operating system. And Linux powers the targets, right? So the web servers, the cloud workloads, the Android phones, the routers, the IoT, almost everything attackers chase runs on Linux. Everything the attacker is looking for, because attacker wants to attack your web servers because they know that that is where you host some of your information. They want to attack the cloud workload. They want to attack your Android phones. They want to attack your routers, your network devices, your IoT, and all of those things mostly run on Linux. Also, Linux powers the tools that we use: Nmap, Wireshark, Metasploit, even Metasploitable operating system, which is like the vulnerable operating system that we use to practice ethical hacking or pen testing. Everything still runs on Linux. All right. So, and these are security toolkits that were built on Linux, right? So, also it teaches you how systems really work, right? Files, processes, permissions, networking. We're going to get here and you're going to see, how some of these permissions work. Some of you guys might have even been seeing some of these things, but you don't even know that this is how they work or this is what they mean. You're going to understand that during the course of this lesson. And now let's try to move around the system. Okay, so when you're seeing a Linux, there is, I mean, when you're seeing a Linux system, we always have a tree, right? Let's say this is home and this is you, all right? You can see that from here, which is you are the analyst. Let's say it is Victor Akinode or whatever. So you'll be able to see that here. And we have like etc, which is like the directory that contains your system configurations. We have your variable, your var, and then logs. So that is where your logs live. We have the TMP directory that contains your temporary files. So everything starts at /, which means the root. Okay, so what you're trying to say is that the root then. So if you are trying to write / something, that means the root then something, right? And that is what that means. I would have loved to write for you guys, but I'm not joining with my iPad. I think my laptop has a pen as well. Let me see if I can get that, but I'm not sure it is charged. But pretty much, I'm trying to use this to explain to you guys, right, that some of this, when you are running / something, right? / something, that means that you are saying that that means you are saying from the root, then / that particular thing. So let me see if I can write with this. Okay, so 1 second. Okay, I think it works now. So here, when I'm saying that when I'm having like analyst here, if you look here, think this is, sorry guys, I don't know why it's not working again. I used it now. Okay. So when I'm saying that, when I'm talking about this, which is like the analyst, so pretty much what we are doing here is you are coming from home and then you're now saying / analyst, right? So this is what is happening at this point. And for the ones that are having like etc whatever, So normally everything, we are saying that everything starts with forward slash, right? So forward slash, let's say forward slash etc. So we are now saying that normally when you are seeing something that starts with forward slash etc, you are saying that you are having root, then forward slash, etc, pretty much. So, but normally, even if you are trying to run your change directory, which you are going to get there, and you are seeing something like forward slash etc, so this will still work, right? This will still work because the forward slash means that from the root, all right, then after root, then the next directory, which is like the etc directory. So pretty much that is what that means. So I can clean that right now. All right, so I hope we understand that that is what I want to achieve with that. So not to be confused with the root user, so same word, different thing. So the forward slash is just, it just means like, okay, maybe you are coming from the root, all right, so and then you are moving to like the next directory pretty much. So because we all have like root of anything, so root of a folder, root of a directory, yeah, directory and folders simply means the same thing, at least in this context. So when you are coming from like the roots, like which is just like I don't want to say home directory because home is even different. Home is different. But when you are coming from the roots, then after root set, that is when you have like home. Home is where you now have your desktop, your documents, and maybe every other things. But we have like different other directories after roots where some configuration files, logs, and other things are saved, right? So we can proceed. Now, when you are seeing something like this, you are seeing commands like pwd lsla cd forward slash, I think I wrote the cd right now, not too long ago, cd forward slash var forward slash log. Then we have like cat alt.log, less alt.log, find something, find forward slash dash name com. So you might be seeing some of these commands. The question is, what do they mean? Now, when you are talking about PWD means present working directory, right? That is what it means. And when you are running that, you are trying to say that Linux should tell you your current working directory. So, like the current directory that you are currently in. So, you are trying to tell Linux to tell you that. So, that is what you are doing with that. So, when you are doing ls-la, so you are trying to list all files, including the hidden ones, with details. So that is what you are doing with ls.la. So you are trying to, though the PWD is, people call it print working directory. So because the command itself is printing the working directory, it's trying to show you the working directory on your screen, but sometimes we call it like your current or present working directory, but literally, I think what the command means is print working directory, right? So then the ls-la, we have ls-l, we have ls-a, right? So we have ls.la. So maybe I should just try some of those things for us so that we can see that. So let me share my entire screen. So after you have uh after you have installed your Kali, so can you guys see my screen? Okay. So after you have installed your Kali, what you need to do is to log in, all right? And then after logging in, you are going to see something called terminal. So I will show you that right now. So we are going to practice this together. So if you are new to it, don't worry. If you are not new, don't worry as well. I will ensure that I balance the class. And that's why I said the class is meant for both the beginners and those that have even already started or that are intermediate guys. So now, when I run pwd, so what I'm trying to say is that print my working directory, and you can see my working directory here, which is /home/Kali. So that is what I'm trying to get. So when I'm trying to say ls, then dash l, right? So what I'm trying to do here is I'm trying to say list all the files, all right, with details. That is what the l dash l means, right? List all the files with details. And that is when you are seeing all these DR, WX, this, you are seeing like one, you are seeing some numbers here. There's a name we call this number, but I can't remember right now. For the files will be having one. I forgot the name they call these numbers. Files are going to be having one. Then this four is just for the directory. So it means that when you open this particular folder, you are going to be seeing like 4 different files there. So I think it's called, I'm coming. Is it a sim link? I think it's number of sim link. I will do research about it, but I think it's like sim link. So, but what this means is that when you open the directory, you are going to be having like something, if you count the number of stuff you are having there, you are going to be having like 4 stuff there. So the ones that are, okay, I think it should be 3 because it's so like this number minus 1. Yeah, I think so. So it's like this number minus 1 or something like that. So I can't really remember right now. So for this one, this should be like maybe you should be having like 7 stuff there. So maybe that should be a 8 minus 1. But we can always confirm to see if to know to remember the formula very well. So let's say we are moving into desktop because desktop is saying let's check again. This is desktop, right? Desktop is having like 8. So if I should run cd desktop, cd means you are changing directory. CD means change directory. You are moving into a new directory, right? So now if I should run ls for this, so let's count the number of things we have here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah. I think it's not minus 1. It's like the total number. So 1, 2, 3, 4, 5, 6, 7, 8. So it will count the number of components that are here, and that is why you are seeing those numbers here. So if you move into downloads here, right, download is having I think it's called Symlink. I can't remember, but I think it's Symlink. So if it is 10, right, and then you moved into download and you try to count the number of files that are there, then they should be 10, right? So you should, if you want to move back, like if you want to move back, you are going to use cd dot dot then forward slash, right, to move back to the previous this thing. So you can use cd for dot dot forward slash, and then it takes you back to where you are coming from. But if you want to move into a directory, you are going to use cd, then the name of the directory. Let's say the directory you want to move into now is like downloads. So they're going to say CD downloads, and you can see that the paths here are changing, right? So now if we should use ls to count the number of things we have here, I mean, we are even having a whole lot here. So, but I think if we count the number of directories, yeah, I think the formula is number of like the symlink number minus, I'm coming. The total number of directories you are having in that particular directory plus 1. Now, I will come again. So I think I'm trying to remember now. The total number of directories you are having in that current directory, in that directory minus 1 is what will give you the number you are seeing here. Let me show you that number again. Is what will give you the numbers you are seeing here. Yeah, the numbers you are seeing here. These ones are like file permissions. These ones are file permissions. But this number here are like, I think it's called symlink. And then, so it is going to show you, like, for instance, okay, I think we considered desktop earlier. Yeah, if you look at desktop now, we have 1, 2, 3, 4, 5, 6, 7. So the ones that are having blue and green are folders, are directories. So the ones that are reserving white are files, right? So if you count the total number of this, you are going to see that there are 7. So 7 plus 1 will give you 8. Yeah, I just knew that it's something minus 1. Yeah, I just remember. So you are counting the total number of directories. So for the symlink number here, if symlink is the name, so for the number here, you are counting the total number of the directories in that directory, right? Or the total number of folders in that directory plus 1 is what will give you this, right? Is what will give you the numbers that you have in here. So also for downloads now, if you count it, you are going to see that if we want to count like the total number of these things, we have so 1, 2, 3, 1, 2, 3, 4. No, I think this is more like, yeah, I think it's a folder. So 1, 2, 3, 4, 5, maybe 6, 7, 6, 7. Then I think we're having like maybe 2 more or something. So I knew I'm coming 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah, 7, 8. Then we have one more. I think that one is here, then 9. So if you now look at what we have here, you are going to see that we are having 10. So for downloads, let's look for download because it will be 9 plus 1, right? So let's look for download here. And if you look at download, you can see that we are having 10. Can you see it? So it's just like the total number of those, directories or something that we counted plus 1 is what will give you this. But if it is a file will always have a symlink value of 1. A file will always have a symlink value of 1. It is only the directory that the number changes. For directory, the number changes, but for others, it's going to have what's it called? A value of 1. I'm coming. Let me remember this thing very well. Is it -1 or -2? I think it's -2 because the directory itself has. I'm coming. I'm trying to remember very well. So I'm coming. Let me quickly search for it because I need there is a formula for it like that. But I don't want to mention. Let me try and copy one. I need there's a formula for it. One second, I'm trying to search for it. So I want to get the name. Yeah, it's hard links. Yeah, I know it's something link. So sorry, like it's a bit long. I did some of those things. So it is hard links, and the 4 represents the number of it's hard link. We call it hard link. And in Linux system, a directory starts with count of 2. I want to be sure. I'm not sure it is 1. So it starts with a count of 2 and then increases based on its content. So a file is 1. A file is always 1. But for directory starts with 2. Directory starts with 2. So by default, directory always have like these things. So if you are counting, I think you're going to count, if you check the number of directories and you are looking for the number of direct subdirectories that are inside that directories, they should be that number of directory plus 2, not plus 1. It should be 2. So I think I miscalculated here as well because this is a file. If you see, you can see .desktop here. You can see that it has an extension .desktop. So it's a file. So the ones that are having directories are the ones having just the blue. So if you look at, you are seeing zap tools, which is 2, 3, 4, 5, then 6. Okay. So then that will be 6. So then 6 plus 2, that would be 8, right? So if you come to desktop, you should be seeing 8. Where is desktop again? Yeah, you should be seeing 8. So that is how it's calculated. Also, if you come for downloads as well, for the ones having blues, those are the ones that are with the folder. So we have 1, 2, 3, 4. Then we have I'm not sure this is a folder, but I think it's a folder. Because it's having .txt, but it's blue color, I think it's a folder. So we have 1, 2, 3, 4. Then we have like 5, we have 6, right? So making 6 that way, then we have 7 and we have 8. So if we scroll again, we'll see that we are not seeing anyone with blue again. So that would be 8. So then 8 plus 2 should give us 10. So if we come here and then we search for desktop, you can see that desktop is having, I'm coming. I'm seeing desktop here is having 8. Which one did you? Oh, download. We are searching for download, not desktop. Sorry. So if we check for download, you can see that download is having 10. And that is how we arrived at that 10. So the ones having blues are like the folders, right? So other colors are not like folders, though I think they can, they can be deceiving sometimes. But other colors are not folders. But the ones that are having blues are the ones that are folders. And to get the hard link number here, you're just going to say, for the ones that are having one, just know that they are files. So there's no calculation for that one. But the ones that are having two, that are having more than one, just know that they are folders. And we are not trying to count the hard link for that particular folder, right? So for this one that is having two now, it means that inside of this folder, inside of this Wi-Fi demo, we don't have any other folder. That is what it means. It means that we are only having files there. So, and we can check. So if you come here and then you do CD, let's say CD, we go back. So also, let me teach you a strategy. If you want to go back and enter another directory at the same time, you are going to use CD space, then dot dot forward slash, and then you are not going to enter the name of the directory that you want to enter. So at that point, you are going back and you are entering another directory at the same time. Do you get it? So if you check it, you can see that once I moved into that and I run my ls, you can see that I'm not seeing any directory there. It is only a file that is there. And another thing is I don't have to move into that directory before I list what is there, because I said ls means list. So if I want to go back now, let's say I want to go back. If don't want to enter that directory before listing what I want to list, I can just say ls, then the name of the directory, which is forward slash, then I'll add like Wi-Fi. Oh no, I don't need to have forward slash here. So I'll just add like Wi-Fi.demo, because if I'm adding forward slash at the back, that means I'm saying that from root, then Wi-Fi demo. Do you get what I'm trying to say? From root, I mentioned it earlier that when you're having forward slash, you're trying to say that from the root, then after root, then the next folder will be this folder that I'm specifying, right? But if you want to move from your current directory into the next folder, from your current directory, and you know that folder you want to move into is like in your current directory, or the path starts from your current directory, what you just need to do is to not add forward slash at the beginning of it. So it can be at the end. You can even remove it at the end as well. But it doesn't have to be it must not be at the beginning. Else it's going to be loading that thing from the root, not from your current directory. So if you do ls this without even being in the directory, it's still going to list the file for you without changing or moving into the directory. So this is how to do, this is how to use some of the Linux command. CD means change directory, ls means list. If you're saying ls, then -l means list all with details. And that means that you are listing all with all of this, right? So I will explain all of this to you as we progress. The D here means directory, so it means the type. So the first three, because all of these are 10, right? They are like 10 digits. If you count one, let's count. One, you are going to count the dashes with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the D here is the type, all right, and it means directory. So if it is a file, you are going to see a dash there. And that is why you are seeing a dash here, because this is a file. Can you see it? So for every file, files are the ones with white color. For every file, you're going to be seeing a dash there. But if it is a directory, that is, if it is like a folder, you are going to be seeing D at the beginning. Do you get it? So now, after D, the first three here is meant for the owner, or maybe for the user, right? So it's meant for the owner, and R means read, W means write, X means execute. So what you are trying to say here is that the owner of this particular folder, or the owner or the user, owning this folder, can read, can write, and can execute. Read means that probably you just want to read something out of it. Probably you want to list, you want to view what is inside. That is reading. Writing is you want to probably add a new file to that directory, or you want to modify the content of the directory. That means you are writing to that directory, right? So if X means execute, that means you can open the directory. You should be able to open the directory, like enter into it directly. and maybe open any file there, double click, open any file, open this, open any directory that is inside that directory. That means you can execute, right? So after the D, the next three values are meant for the owner. Don't forget. Then after that, we're having another RWX. This one is meant for the group. Inside Linux, we have a group. A group is just like, for instance, you are just getting, let's say you just got a job at Access Bank, okay? And you are getting, and probably as you are entering as a security analyst in Access Bank, right? And as a security analyst, when you are being employed, you are being employed with a lot of people, let's say with about 30 other persons. And with you, that makes the numbers 31. So they are having like new 31 security analysts. But you guys are having the same role. And you guys are going to be having the same permission. You are going to be accessing the same files or be doing similar things, right? So instead of they creating user one after the other, and then setting permission that we want this user to execute, we want this user to do this, we don't want this user to do this, they can create a group and then set permission to that particular group and then add all of you guys, all the 31, and dump you inside that group. All right. So the moment they add all the users inside the group, the group permission applies to all the users. The group permission applies to all the users, right? So, and that is the essence of the group. So instead of you setting up permission for each user one after the other, you can create a group, set permission to that group, carry all the users, dump them inside the group, and then the permission for the group will be applied to them. Is that clear? I want to know, please, if it is clear, I want a reaction in the chat section. Is it clear? Is it clear? Can I proceed? Is it clear? Are you enjoying the class? Can I proceed? Okay, makes sense. So, and we have others, right? So others are the ones that are not owners and they are not groups, right? So, and others could be maybe some services within the system that probably just need that particular file to do anything. So if others want to use the directory, others only have read and execute. You can see that the W there is dash, the space for W is dash. So others can only read and execute. They cannot write to that directory. Is that clear? So I think my time is fast spent already. I'm getting the notification here, but I'm trying to just see, okay, I have 4 minutes left. Okay, so let me see what I can do with that. So at least I've been able to understand like the basics to you guys. So you guys, don't worry, I'll just beg for like maybe extra 15 minutes to quickly complete what I have started, right? Just extra 15 minutes, I beg. So, yeah, we can continue now. So I think for some of these things you guys have seen, you've seen something like, okay, for ls-la, that means that you are listing all, right? So all means you are listing with hidden files. Hidden files are the files that start with dot something. If you look at what we have here, you can see that none of those things is having dots here. None of it is having dots. So now hidden files are files like .ssh or directories like .ssh, .this, .that. You cannot see those ones with your naked eyes, right? If you are moving or you are using the GUI means the graphical user interface. That is, where you are clicking let me show you something like that. So maybe in this situation where you are doing double clicking, opening this, opening that, so when you are using the GUI like this to move from one directory to another, you cannot see those hidden files. All right. Unless maybe on servers, there are things you can toggle on to see hidden files on servers, right? But here, probably there will be some extra settings you need to do. But if you want to do it easily, what you can just do is just to use maybe -A. You can use -A alone. -A will show you all the hidden files, but it won't show you the permissions for each of them. And if you start looking at this, you can see this is having dot, this is having dot. So these are like files we couldn't see the other time when we're running ls-l alone. But if you now want to see all these files with their respective permissions, that is with more details, you want to see the hard links, you want to see the permissions attached to each of the files and directories, then that is when you're going to run ls-la, right? And you can see like all the files, including the hidden files and hidden directories. You can see the hidden directories, which is that .ssh, And you are going to be seeing them with their permissions, with the what's it called, the hard link numbers as well. So that is like the difference between the ls-l, ls-a, and ls-la. I hope it's clear now. Okay, so let's quickly proceed into like the next one. So maybe I won't be, I think I've been able to explain a bit, so I won't go to Kali again. So you can use less, you can use cat. Cat is you want to read or you want to show the content of a file. So if you use cat, so thing is going to show you like the content of that file. Maybe I should quickly do that for you guys as well so that you can see. So let's say we want to pick a file here. Let's pick a file. Let's say we want to pick something like alt scan this, so something like this, alt scan 3.nmap or something. So if you want to pick that file, so we can say cat, all right, and then the name of the file, and we run it. You can see this is the content of the file. So even if you use GUI to open the file, this is what you're going to be seeing in the file, right? This is what you're getting. So it's more like you are opening Microsoft Word to read the content of a file. That is what the command cat means, and the full meaning is concatenate, right? So that's what it means. Let's come back here and then continue our class. So let me put it on slideshow again. So then if you have less, you can see, you can practice some of these commands on your own. So now permissions and who can do what. So in real world, a misconfigured file permission once exposed millions of AW3 S3 records, and one wrong change mode can lead to one big breach, right? So change mode, ch mode means is the command you can use to change mode. I will recommend some videos for you guys at the end of this class that you can watch to explain this better. I'm having limited time already, so I think the admin thing I did at the beginning of the class took a lot of our time. So now this is what I explained the other time. So dash is for the first character here is for the type. So for file, you're going to be having dash. For directory, you're going to be having D. So, and you can see that this is for the user, that is the owner, user, group, and then others. And you can see all of that here. So then after that, commands that you're going to live with, all these commands are very important. So there's a calculation I should teach you guys. Maybe we should end the class on that note. Once you understand that, I think you are good, right? So we have that. We have ls-l. Sorry, guys, I have an order. Let me just mute myself. 1 second. Okay, guys, I'm back. So now I need to do a calculation for you here quickly. So I want us to quickly look at it together. So these are some of the commands that you're going to leave with ls-l, then the name of the file to view permissions, change mode. That is you want to change the mode of a file, right? So now each of this, you are seeing 755 here. So each of those things means, or each of the three, the first number is meant for the user or the owner. The second number, which is 5, is meant for the group. The last number is meant for the others, right? Now, for 7, R, if you're looking at R is 4, right? Which is read. And then what's the name? Write is 3, W is 3, and then X is, who is this guy again? Who's writing on my screen? So R is 4, W is 3, and X is 1. I'll come again. R is 4, W is 3, and X is 1. Now, if you want to calculate this very well, you are going to see that the 7 here means that the user can read, because if you want to calculate, you say 4 plus 3 plus 1. That is, no, it's not. I think W is 2, not, no. W is 2, not 3. R is 4, W is 2, then what's it called? X is 1. Sorry, I made a mistake. R is 4, W is 2, and X is 1, not 3. So because it's like divided by 2, divided by 2, divided by 2. So R, which is 4, divided by 2 will give you W. W, which is 2, divided by 2 will give you 1, which is R, right? I mean, which is X, right? So now, if you want to add the 3 together, if you say 4 plus 2 plus 1, that is 7. So where you are having 7, that means that you are saying that the user will be having the read permission, the write permission, and the execute permission. Let me write it down so that you can understand. 1 second. So if you can get this, I think you can read the rest of the slides yourself and you are going to understand. So now let's say, let me use this, then pencil. Yeah. So now I'm saying that R is Can I write now? I don't know why it's not writing. Okay, let me just quickly use a note then instead of using this because I don't want to waste time. Let me try and duplicate. Okay, 1 second. Let me duplicate something here. Okay. Duplicate slides. Yeah, okay. So I can. 1 second, guys. I want to see if I can write here. Okay, so let me just use this. So now I'm telling you that my R is equals to 4, right? W is equals to 2, and then X is equals to 1, right? Now, that is the concept. Because 4 divided by 2 will give you 2, then 2 divided by 2 will give you 1. And that is how we transition from R to X, like R to W, then to X, right? So now, if I'm saying that I'm using the keyword change mode, right? So this means change mode. We have another command which is change ownership, right? So that one you can use it to change the ownership of the file. So let me try and increase this a bit. So that one you are using it to change the ownership of a file. So we have like 2, but we want to use change mode right now, which means we want to change like the mode for the file, and that means that we want to change the permission for that file. So in this case, if I'm saying that change mode 755 and I'm adding the name of the file, let's say the name of the file is file.txt. So what I'm trying to say here is that the 7 here is equals to, because you're going to look at what will make up 7 for you. Okay, if you want to look at is what will make up 7 for us, we are going to have R, because R is 4, isn't it? So that will be R plus what? Plus W, right? Plus what? Plus X. So because if you add 4 plus 2 plus 1 will give you 7. Am I correct? So if you have 4 plus 2 plus 1 will give you 7. Is that it? So now if you want to achieve, let's say you want to achieve 6. So how are you going to achieve 6? So definitely you know that 6, what will give you 6 is 4 plus 2, isn't it? So then you are trying to say that R plus what? Plus W. Because those are what will give you 6. So that is what will give you 6. And that means that X is going to now be having dash instead of having the value of X. And that is why you are going to be seeing some places having dash there. Do you get? So if you are running a change mode, and you want to change something to, let's say you want to change it to 766 or 755 or so. Okay, let's say it's 766. So here now, at this point, you are getting 6. Let's say you want to get 5. So what does 5 mean? 5 means that you want to read and you want to be able to, what's it called? You want to be able to execute at the same time. So definitely the path for W is going to be what? It's going to be dash. So instead of seeing RWX, you're going to be seeing R-X, right? So here now, instead of seeing RWX, you're going to be seeing RW dash. So let's say you are looking for the one that just have to do with 4, okay? So you know that you're just having just R, then dash dash. So which means that only read is 4, then the rest will be dash. Okay, so if you are looking for maybe something like, which other value can we get again? 3, you want to get 3. You already know that 3 will be W plus X, because that will be 2 plus 1. Are you getting what I'm trying to explain? So that will be 2 plus 1, and that will now be W and what? And X. So which means that your R will be carrying dash, your W will be carrying W, and your X will be carrying X. So that means that a particular user that is having this permission will only be able to write and execute and not read. So the person having this permission will only be able to read, not execute, and not write, or not write and not execute. So here, if you look at this person will be able to read, not write, but execute. So the person will only be able to read and execute. Is it clear, or I'm just explaining nonsense? Is it clear? So that is the permission you are seeing there. And that's why I had to break it down for you. So if you can understand this, I think you can understand the rest of the slide. So you can read up and understand yourself, because another mentor will come up very soon. I know it's a lot for you guys, but you guys just need to pay attention and read and read and read and read. So now if I want to get something of 755 now, so that means that my user, Abi, right? My user will be having what? My user will be having 7. And 7 will give me RWX, because that will be 4 plus 3 plus, 4 plus 2 plus 1. That will give me 7, right? So, okay, so let me just say equals 7, right? So, and my group will be having what? So I want to see if you guys understand, because we're having 5, right? We're having 755. So group is going to be having what? Group is going to be having what? Group is going to be having Rx. Thank you so much, Mary. You got it. So group will only be having Rx. So then we are going to be having R-X. Do you get it? Sorry, R-X. Because the place for W is not there. So we are going to be having R-X. And after that, we are not having for others, right? So for other, we are going to be having, because it is 5, we are going to be having R dash X at the same time. So let's say you want to do change mode, let's say 766 or 764. So now what will user have? The first person, what will user have for 764? User is the owner of 7, right? Group is the owner of 6, and order is the owner of 4. So, okay, 7 RWX, thank you so much. That means you guys are good. So group is going to be having what? Group, you will be having what? RW dash, thank you so much. Then order is going to be having what? Order or orders, whatever. So it's going to be having what? Because it is 4, that will be what? Order is going to be having what? Because it's all R. So that will be R dash dash. So this is how to, do the Linux permission. And when you come here, that is what you are pretty much seeing in your Kali. So because some of you guys might be wondering, how are they getting this? How are they calculating it? So you can change anything, right? You can change anything. So if you are doing ls-la, right? So for this now, let's pick a particular file, and then let's try to do one small thing on it. From there, we can just call it a day. So let's pick this, right? So normally you are seeing that this is having dash, which is meant for directory. That place will be having dash because it's a file. So we're having RW dash, right? So we're having R dash dash, and we're having R dash R. That means user will be able, or owner will be able to read and write, not execute. group will be able to read only, not write, not execute, and other will be able to read, not write, not execute. So now if I want to make this file to be, let's say I want the user to be able to read, write, and execute. I want group to be able to read, write, and not execute. And I want the order to be able to read, not write, and execute. So now let me try and do that now. So let's copy the name of the file. To copy the name of the file, use Ctrl+Shift+C. You highlight it and use Ctrl+Shift+C. So let's copy the name of the file. Now we want to change the permission, like the file permission. So to do that, you're going to run change mode to change the file permission. There's a lot of interesting stuff around this. It's just because of time, you'll not be able to teach all. But there's a lot of interesting stuff. So now, if I'm changing that, I said I want the user to be able to read, write, and execute. So that would be 7, right? Because I'll be having 4 plus 2 plus 1, that's 7, right? So I want the group to be able to read, write, and not execute. So that would be like 4 plus 2, that would be 6, right? Because that is read and write. So then the last one, I want the order to be able to read, not write, but execute. That would be 5, because that would be 4 plus 1. So if I now add the name of the file to it, and I run this. So I will have to add sudo to do that, because it's not allowing me to change this thing. So sudo means that I want to use like the admin permission to change it. So then if I run it, now I've been able to, okay, it's going to ask for my password. Then I've been able to change the permission, right? So sudo means super user do, for those who don't understand that. And sometimes there are things you want to do as a normal user that you won't be able to do. But if you use sudo would use the admin privilege to do that thing for you. So it is still about privilege thing that we are talking about, right? So yeah, because because of the location of the file, right? So yeah, you can't just do anything with it. So now that we've changed the mode of the file, now let's now rerun L-LA and try to see, let's look for the name of the file again. So I think the name of the file we copied earlier was altrecon1.txt. So let's look for that, altrecon1.txt. This is altscan, altrecon1.txt. Do we have the file? Okay, yeah, you can see it here now. And you can see that the color has changed. So now look at it. Here you are now seeing RWX. That means user can now read, write, and execute. So here RW, you can see RW dash, which means that group can read, write, but not execute. And here you can see R dash dash. Oh, what did we use? We used 5, right? Oh, sorry, I'm looking at this. It should be this, not that one. So here we're having RWX, RW dash, and R dash X, which means that the 5, who is Hugo that is writing on the screen? Hugo, you are writing on the screen. And now it's affecting what we're doing. So now we have R dash X, which means that user can read, not write. Order can read, not write, but execute. So they can read and execute, but they cannot write. And that is what you are seeing here. So that is how they change mode of a file in Linux. So in case you want to change permission, you want to do stuff, that is how you can do that in Linux. So I think I'll be stopping here. Maybe my next class, if you have questions, so try to go through all of those things again, and it's going to really help you understand that better. All right, thank you so much, guys. So we'll be bringing up the next mentor to continue with today's class. Yeah. All right, thank you. But that is how you guys already understand Linux now. So you guys are good. You are Linux good. So I will share the slides with you. You can read up on the slide. I will share the notes with you as well. And the recording is going to be shared. So in case you didn't capture it in class, please go through the recording again and again. I've spent a lot of time already. So Idris, Ibrahim, you can come up. All right, thank you guys. Ostus.
Yeah, thank you very much, sir. Mr. Idris, if you're there, can you raise your hand? And then let's bring you up. Thank you very much.
Okay, so maybe pending when that is done, let me quickly get someone is okay, Idris is up already. So you can give him the mic. So I gave you the permission already. So Ibrahim, you can unmute yourself.
Yeah, good evening, everyone. So hope you guys can hear me. Yes, so just a
Yes, we can
reaction.
hear you.
All right, thank you very much for the wonderful session, Mr. Victor. And yes, we are going to continue on this amazing class with I want to be learning about SOC, right? So I'm going to be learning about SOC. Let's quickly dive in. So, first of all, my name is Ibrahim. Idris. I'm going to be your SOC mentor for this class, or I'm going to be the person who's going to be in charge of this class. So, we're going to be talking about Security Operations Center, SIM, and also log analysis fundamentals, right? So, let's quickly dive in. All right. So, we're going to first of all, I'm going to be talking about what I'm going to be covering today. I'm going to be covering 10 topics. I'm going to try as much as possible to summarize, not just summarize, but I want to try as much as possible to make sure you guys actually learn something from this and also at the same time summarize it because we have limited time. We have 10 topics. First of all, we're going to be talking about what the SOC really is. What SOC, that's Security Operations Center, right? What a Security Operations Center really is, or actually is. What's this thing called Security Operations Center? What's it all about? We're going to be talking about that today. Next one, I'm going to be talking about SOC analyst rules or the different rules in SOC, right? You have
Can you
L1.
share your screen? Can you share your screen?
Oh, sorry. I forgot. I thought actually I was sharing my screen. Sorry for that.
Yeah.
All right. Thank you very much. I believe you guys can actually see my screen right now. So let me quickly start from slide one because I thought I was sharing my screen. All right. Thank you very much. So as I said, we're going to be talking about Security Operations Center, SOC, and also SIM and log analysis fundamentals. Let's quickly dive in. So these are the topics we're going to be talking about, or these are the topics we're going to be covering for today. First of all, we're going to be talking about what a SOC really is, what this SOC of a thing, what's it all about, how you can actually navigate through the SOC workflow and all this stuff. Next one, I'm going to be talking about SOC analyst rules. We have the level one, level two, and level three, right? Or tier one, tier two, or tier three, depends on what you want to call it. And then we're going to be talking about the daily SOC workflow, how a slog actually works, like um, a day-to-day activity of the SOC actually and of a SOC analyst. So we're going to be talking about SIM platforms and how they work. So I know you guys might be, this is the second time I mentioned SIM. What's even SIM? We're also going to be talking about SIM. It has a full meaning. This is just an abbreviation. The full meaning of SIM is Security Information and Event Management. So I'm going to be explaining what a SIM actually is as we move on. Next, we're going to be talking about alert and alert fatigue, right? I'm going to also be explaining what that actually is. Next, we're going to be looking at log analysis fundamentals. And this is where we're going to be getting our hands dirty with the SIM platform, right? We're going to be doing some little investigation like real analysts. We're going to be talking about network-based detections, right? Or attacks. We are going to understand as we move on to the class. We're going to be talking about MITRE attack basics, right? Attack is a framework. I'm going to be explaining that as we go on in the class. Just don't worry, this is just like a summary of what we're going to be covering today. We're going to be talking about firewalls, IDS, and also IPS. IDS meaning intrusion detection system, and then IPS meaning intrusion prevention systems. And then we are going to be doing a hands-on SOC investigation exercise in which we're going to be dealing with a real-life scenario style stuff, and we're going to be doing some investigation. So let's quickly dive in. First of all, what is a security operations center? I know most of you, or let me say some of you might have heard of the term SOC or Security Operations Center, right? Security Operations Center is just like a control room. It's a control room, right? It's a control room. There's a lot of things that happen in that particular control room for cybersecurity or cybersecurity control room, right? It's a monitoring system. It's a control room that actually monitors system and also networks 247, like 24/7. There's no rest when it comes to a SOC. A SOC is never at rest. That's just a SOC. So it's just a control room in which SOC analysts are people who work in SOC or work with security operations center or SIM platforms and whatever tools that has to do with security operations center, right? They monitor events 247 in order to detect attacks before they even happen, right? So it's a monitoring system, and it's a monitor system and network 247. It also helps in detecting attacks, not just helps. That's one of the purpose of a SOC. It's a control room, and I personally like to call it the first line of defense. SOC is the first line of defense of every single organization. For SOC is the first line of defense. Actually, SOC analysts detect attack before they even happen, and sometimes even protect or defend against some particular attacks before they will reach the network. And it also helps in investigating suspicious activities. Whenever there's something you feel is suspicious in your network or your environment, you can just reach out to your SOC analyst, or SOC analysts use what they can do to check or to figure out whether it's it's something to worry about, or it's just a normal network activity. And also, SOC is used in responding to incidents quickly, like very sharply and quickly. Right? It helps in reducing business damage during attacks. This this actually very legit when it comes to SOC. It helps in reducing business damages during attacks, during cyber attacks. Even if the attack occurred, actually, it helps in reducing some business damages and a lot of stuffs, right? So let's do some reality check. Attackers do not sleep. Actually, hackers do not sleep. As we all know, hackers are people who actually wear hoodies in the middle of the night and try to do some nasty stuff. That's not actually what a hacker actually is, but let's just go with that. So attackers do not sleep. Most organizations are attacked daily, on a daily, not even hourly, millisecondly, whatever you choose to call it. Yeah, right. Many organizations are being attacked daily. So the SOC exists to detect attacks before they become a disaster or before they even happens in some situations. That's basically a SOC. But that's a security operations center. Let's talk about a real life situation, an attack that actually happened, where a SOC could actually help, or maybe where a very good SOC can actually help, because I believe they had a SOC system, but not a very strong SOC system, right? Let's talk about the 2021 Colonial Pipeline attack. The Colonial Pipeline is a oil pipeline for, like, it's an American oil pipeline, right? Where they deal with oil and gas and all this stuff. So in 2021, the attack happened in 2021, just let's say 5 years ago, just 5 years ago, and a lot of attacks are still happening, right? In 2021, Colonial Pipeline suffered a ransomware attack that disrupted fuel supply across the United States, the US. Attackers gained access through compromised credentials, aka social engineering or credential harvesting. I don't know if you guys know what social engineering is. It's a type of cyber attack. You guys can just make research about that and just learn more. And I would actually appreciate it if you guys maybe have like a book or something. You're just jotting down some stuff, maybe to ask questions and also to do some further research. Because I want to try, as I said, I want to try as much as possible to summarize stuff. So I'm not going to explain that deep, right? So when this attack happened, what um what did the SOC has to do with this, or what if they say there's an active SOC in that particular oil industry or that particular oil company? What is it that it will do? The SOC should have detected a lot of things, like suspicious VPN login activity. Obviously, you can't log into their system if you're not from maybe a particular region, maybe if you're not in the US, and maybe the hackers are not even from the US. So obviously they need to use a VPN in order to, to trick the system into believing that they're actually in the US. So SOC should actually SOC actually identifies or detects suspicious behavior, or SOC analysts rather, because SOC analysts actually do the investigation. So it should have identified suspicious VPN behaviors from an unknown location, or let me say, not unknown location, a location that's not actually, that have never connected to that particular systems or company, something like, or a login that has nothing to do with their staff, right? That's one of the things that the SOC should have detected. It should have detected, but this is just like some loopholes and one of the reasons why the attack actually happened, right? Then unusual authentication pattern. Obviously, the authentication pattern the attackers are going to be using is not the same with the person whose credentials they use to log into that particular system in order to carry out the attack. I don't know if you understand what I say right now, but I believe you guys understand. So the SOC actually has to, or the SOC should have been able to identify unusual authentication patterns. Let's say, for example, I work as in the company as maybe like IT personnel, or cybersecurity personnel or software developer, whatever it is. Maybe I just work in the company, and okay, my working hours is from 7, okay, let's say 9 to 5, from 9 a.m. to 5 p.m., right? And then this authentication, or the system was being logged in, let's say at 5:30. Obviously, I will still be in the office by 5:30, right? So it's not going to be something that's going to spark up a lot of suspicion, right? But still, it's an unusual authentication pattern. It's not normal. Maybe the employee normally leaves by 5 p.m., but it's 5:30. It's not suspicious, but it's not normal. That's one of the things the SOC should have, or SOC analyst should have detected, right? Lateral movement inside the network. Lateral movement is just the attacks moving from one system to another, maybe from one system, from a less privileged system or to a more privileged system, something like that. So that's basically lateral movement, right? Lateral movement is also like an attack pattern that hackers actually use. Then abnormal outbound traffic. When we are talking about outbound traffic, right, it's traffic that's coming into the network from another source. That's basically outbound traffic. And then we're also going to be talking about why it's important to have a bit or some particular level of networking knowledge as a SOC analyst. As you can see, outbound traffic or this outbound stuff has to do with networking. So if to say I don't have networking knowledge, I will not even know what outbound traffic actually even means, right? Or even is. So that's basically, so abnormal outbound traffic. The SOC should have detected an abnormal, incoming traffic or an abnormal traffic coming from the outside network. I'm going to explain what this traffic is, or log. I haven't mentioned log yet, but I want to explain what this traffic actually is, right? Just stay with me. So, what failed? What failed that actually led, or what we think, because we are not there when the attack happened, what we think failed, or what I think failed, since I'm the one who designed the slides. So what I think failed that led to the attack happening in the SOC, right? So, first one is weak monitoring. So all this stuff I just mentioned, right? The SOC should have detected this. The SOC will not detect this on its own. The SOC analysts who are supposed to be monitoring whatever activities in the SOC are supposed to be the ones, doing all this stuff, checking for suspicious VPN login activity, checking for unusual authentication patterns, checking for literal movement inside the network, and also checking for abnormal outbound traffic. So weak monitoring. The SOC analysts not actually, I will not say they did not do their work well. Maybe the attackers were being very sophisticated, but weak monitoring is one of the reasons that could actually, or that led to this. Next one is poor alert prioritization. We are going to be talking about this more when we come to alert fatigue, poor alert prioritization. Maybe the alert popped up, but the SOC analyst had like 30 others or 1,000 other alerts they should attend to, and then they see, okay, this alert maybe is a low priority alert or it's a false positive. I'm going to be explaining what a false positive is. Just bear with me. Maybe this is a false positive, or this a low severity alert, something like that. So they did not actually prioritize the alert well. So that is why they were not able to respond to the incidents on time or early, until it's, give the attackers enough time to get access to the system and do whatever it is they want to do, right? And it's a ransomware attack. I believe you guys know what a ransomware attack is. If you don't, I will actually appreciate it. You can just write it down to make a research about it, because I don't want to explain, or I don't want to go deep into that, right? Sorry for that. So delayed response. Maybe the tier one SOC analyst or the level one SOC analyst, I want to explain what a level one or level two or level three SOC analyst is. Maybe the level one SOC analyst saw he saw the alert popped up in the same tool or something like that, and then escalated it to the level two analyst or level three analyst, but it was delayed, or the response was being delayed. That could be one of the reasons why the attack actually happened, or that's one of the reasons why, yeah, the attackers were able to gain access into the systems, right? So defender takeaway. As a defender, what's your takeaway, or as upcoming SOC analyst, what's your takeaway regarding this attack? Let's quickly call it. A SOC analyst is not optional in modern organizations. Yes, it's not optional. There's no way it's optional in modern organization, especially in modern organization. There's a reason why I emphasize on the modern organization. It's not an option. It's not optional. It's a must for you to, have a SOC. So let's move on. The structure of a SOC. The structure of a SOC. from level 1, level 2, level 3, how a SOC is being structured, actually. Understanding the analyst tiers, as I said, you can call it tiers or levels. First one, we have the L1, which is the level 1 or tier 1, whatever you choose to call it. Personally, I like to call it tier 1 SOC analyst, but let's just go with level 1 SOC analyst. Level 1 SOC analyst, right? What they do is normally as a level 1 SOC analyst or a tier 1 SOC analyst, their job is also to monitor alerts. Whenever there's an alert being popped up in a same tool, I know we're going to get into the practical aspect. You're going to see what I mean by alerts and all this stuff, right? I know you guys might be confused. That's why I say you should just be jotting some stuff down so you can, just reference back to them later on. So the job of a level 1 SOC analyst or the job of a tier 1 SOC analyst is to monitor alerts. All he does is monitors alerts. Whenever there's an alert, okay, he's the first person to, respond to that particular alert or try to triage that alert. So triage just means investigation or responding to that particular alert. Then next one is initial triage, as I say, initial triage. Then after the alert is being triggered, okay, he's monitoring for alert. Then okay, an alert just popped up. The next thing he needs to do or he's going to be doing is initial triage, meaning he's going to be investigating that particular alert. He is going to start the investigation. Just pardon me, he's going to start that particular investigation. He's going to do some little investigation. Okay, why was this attack, or why is this attack even being triggered, or this alert, sorry, being triggered? Why this, why that? He's going to try to answer some few questions. And yeah, that's one of the job of a tier 1 or level 1 SOC analyst. So after that, after he sees an alert, he tries or investigate the alert. Next one, he's going to escalate the alert or incidents. Since obviously, if he's escalating the attack, then it's actually an incident. He's going to escalate or escalate the attack. But before he escalates this alert, he needs to send it to a tier 2 SOC analyst. So the tier 2 SOC analyst can be like, okay, yeah, this alert actually needs to be escalated, or this doesn't deserve to be escalated. This is a false positive. I'm going to be explaining what a false positive is. So that's basically the work of a tier 1 SOC analyst. And then we have first line of defense. As I said, the first analyst is the level 1 SOC analyst is the first person or the person who is going to first, receive the alerts. Whatever it is that's coming into the network, the tier 1 SOC analyst is going to be the first person to have a look at that, or have a thought or just see it, something like that, right? So basically, or obviously, he's the first line of defense. Although the SOC in general is the first line of defense, but in this case, he is also the first line of defense. This tier 1 SOC analyst, and that's actually like the first stage I'm going to, like the entry level position of a SOC analyst. So next one we have the tier 2 or level 2 SOC analyst. What does a tier 2 SOC analyst do? First of all, deep investigation. After, okay, as I said, level 1 SOC analyst is like an entry level. So the level 2 SOC analyst, who is obviously more knowledgeable and also more experienced in the field of SOC, is going to do some deep investigations, right? He's going to go in, okay, maybe after the tier 1 or the level 1 SOC analyst is done with his investigation, he's going to write a little report to forward to the tier 2 SOC analyst. Okay, let's see, I noticed that there's a suspicious login activity from this particular IP address, and I think this might be a brute force attack, for example. Then he sends the note to tier 2 SOC analyst. The tier 2 SOC analyst look at it and be like, okay, let's see. He's going to try to do some more deep investigation and see if it's actually a brute force attack, or it's just maybe an administrator who forgot his password, or maybe trying to log in from home, or trying to work from home, or maybe an employee who's working from home. So, and then maybe the system flagged that as an unusual login attempt because maybe he's used to working from the office or something like that, right? Sorry. That's basically that's one of the job or tasks of a tier 2 SOC analyst or level 2 SOC analyst. Then he correlates logs. When I say correlate logs, is that he moves through logs, he search through logs to find a lot of stuff, or to check for a lot of stuff. That's just the part of the process of investigation. Correlating logs. So we are going to also be correlating logs in this class. So he confirms malicious activity. So after all this, he's going to confirm, okay, this activity is actually malicious, or this is a malicious activity. So after that, what does he do, or what is next step, or what does he do next? So next is containment steps. Containment is actually like all right, this is actually okay, this is an incident, this is system, um, this is a system that's been affected, and he's going to start containing the system, and also started he's going to start thinking of ways to forward that to a level 3 SOC analyst, who's also known as an incident responder, to isolate, eradicate, and do some incident response procedures on that particular system or endpoint, whatever host that's been affected, right? That's basically the task of a tier 2 SOC analyst. Sorry. Next one, we have level 3 or tier 3 SOC analyst. What's the job of a tier 3 SOC analyst? Right. First one is threat hunting. Threat hunting is actually you looking for things in the log. No, let me not explain it that way. For example, tier 1 SOC analyst, what a tier 1 SOC analyst do is monitors alerts. When an alert is being triggered, he does initial triage, escalate the incidents, and blah blah to the tier 2 SOC analyst, right? But in this case of the tier 3 SOC analyst don't wait for alerts. He just dive into logs and just dives into the log, search stuff in the log, just trying to look for unusual activities or suspicious activities in the logs. Maybe something came in, or something passed through the alerts, right? Something passed through the alert, and alert was not being triggered, and maybe there's something in the system. Maybe an attacker actually even have access to a particular system in the organization or in the environment, and then the tier 2 organized would be like, okay, let me just scroll or search through this log and see if there's anything suspicious, or if there's anyone trying to do something he is not supposed to be doing. In some cases, it might not be even attackers. Maybe the employee might be doing something he is not supposed to be doing, which is also known as insider threats, right? So that's threat hunting. That's one of the tasks or work of a tier 3 SOC analyst, also known as incident responders. Sorry for that. Then malware analysis. He is also responsible for analyzing malwares. Let's say, for example, tier 2 SOC analyst, you know, manages to do some investigation and confirms that okay, an attacker actually has a malware installed in a particular system in this particular organization. A tier 3 SOC analyst is going to be the person responsible for analyzing that particular malware. So when we say analyzing the malware, he's going to check, okay, what is the use of, okay, first of all, what type of malware is this? Is it a Trojan horse? Is it a ransomware? Is it a virus, a worm, whatever it may be? There are different type of malwares, right? You can just also write that down and search about that. There are different type of malwares. We want to analyze that. So after that, what is actually this malware doing? What is the purpose of the attacker putting or installing this particular malware in this system? So that's malware analysis. After that, then just analyze the malware. So that's the work or task of a tier 3 SOC analyst or a level 3 SOC analyst. Then detection engineering. Detection engineering, you might have heard me talking about alerts. You might be thinking, okay, if someone install this SOC, does it automatically knows when an attacker is trying to do something malicious in the endpoint or in the organization? Actually, no. These tier 3 SOC analysts are responsible for creating those alerts, right? Um we're going to be also be talking about how the alert is being created, or like how it's being created and how it's being triggered and all this stuff. So it's he is responsible for creating those particular alerts, right? He is responsible for creating those particular alerts. That's one of the work or tasks of a tier 3 SOC analyst. And then advanced investigation in some is that's incident response. After the incident is being confirmed, so he does some advanced investigation, like okay, since we know that okay, an attacker is trying to do something to us, or he has actually done something in our network. Okay, how many which information has he gotten his hands on, right? And apart from this host, is there another host that the attacker has access to? So that's the type of advanced investigation we are talking about, right? Sorry. That's the task or the work of a tier 3 SOC analyst. Next up, we have SOC manager. SOC manager is responsible for overseeing operations, whatever it is that's going on in the SOC. He's responsible for overseeing the operations. Obviously, from the name manager, we already know that's his task. And then he's also responsible for coordinating incidents, right? Whenever there's an incident, in some cases, um, the SOC manager, you know, decides who investigates a particular alert and who does this or who does that. You might be okay. Let's say, for example, we might have like 20 level 1 SOC analysts in a particular organization, and then we might have 1,000 alerts in that particular team organization. Then the SOC manager is responsible for okay, this alert is going to be yours, this alert is going to be yours. It doesn't work that way. I'm just trying to explain it to you guys so you can understand. Obviously, it's automated, but I'm just trying to explain to you guys so you can understand. So it's responsible for coordinating incidents. And also, whenever something happens between these three life cycle, the level one, level two, level three, the person who they're going to be forwarding the reports of whatever it is they have done or whatever investigation they have done to is the stock manager. So he's going to, have the final say. Sorry. So what one of the things actually a SOC manager also does is report metrics and risks. So you might be thinking, who does he report to? Right? So as a SOC analyst, there's a point you will reach as a SOC analyst. Most SOC analysts are actually technical guys. There's a point you will reach as a SOC analyst. You need to know you know, how to communicate these incidents to non-technical people, because this SOC manager is going to be communicating whatever it is, or he's going to be gathering all the reports, all the metrics, all the statistics of incidents or attacks they have been getting, and all this stuff, to the let me say, what did they even call them, or let me say to the board directors, or to the um to the non-technical people of the organization, actually people who are just handing up the reports to the non-technical, let's say the non-technical people, maybe the CEOs. Depends on the hierarchy of the company, actually. Let's just say the CEO. So he's going to be sending this report to the CEO. Obviously he should know how to create a report that a non-technical person would understand. So I know that's one of the work or tasks of a SOC analyst. So next one, let's talk about how SOC analysts think, or how you can think of like a SOC analyst, right? Let's learn how to think like a SOC analyst. But before I even continue, even you guys, are you guys with me? Are you like understanding what I'm doing? Am I too fast? Am I too slow? And yeah, I don't. One person can just unmute his mic and let me know so we can continue. All right, we don't have much time, and we also have some practical stuff to do. Let me just quickly continue. Right, what happens when an alert appears? Still, I'm going to talk about how this alert thing actually comes up, how it's being done. So first thing that happens when an alert is being popped up, or when an alert is being triggered, is this alert real? Like, is it a real alert? Is it something to worry about? That's the first thing that comes to a stock analyst's mind when an alert is being triggered. Is it a true positive? Is it a false positive? Whatever it may be, is it real? Right? The next one, what system is being affected, or what system was affected by that particular alert, or by that particular alert attack? Because anytime an alert is being triggered, obviously there's an attack. Next one, we have which user is being involved, right? Which particular user is being involved, or which user credential is being involved, something like that. So which user is being involved, very important. And then how severe is this? It is something to worry about much. Every single cybersecurity incident is something to worry about, but like, how's the severity level? Like, is it severe? Is it something to worry about, or is it something just worry about? I don't know if you guys understand, right? Then, is this part of a large attack? Is it like, let's say for example, alert is being triggered. Is this something that is new, or is it something that has been going on but we are just knowing now? That's basically what this means. Is this part of a large attack? Has it been, going on for a while? Then while our system is just flagging it now, or has it been going out, or is this just new, or a new attack? That's basically what this is all about. Then what should happen next? So after all of this, what should happen next? That's basically how SOC analysts think. Well, that's basically the first thing that comes to a SOC analyst's mind when an alert is being triggered, right? Let me just quickly take this up so we can see what's on the bottom. So, also an important thing you guys should note: the analyst's job is not just reading alert; it's making decisions under pressure. Because believe me, when there's a cyber attack hits the company, everyone is under pressure, because you never know how far it has gone until you do some investigation. So everyone is under pressure. You need to know how to act, or how to how to be calm under pressure as a SOC analyst. Sorry, Father, let's quickly continue. So the daily SOC workflow. Let's quickly talk about the daily SOC workflow. What happens like in the day-to-day activity of a SOC, right? First on, monitoring dashboard. Obviously, SOC analysts monitor dashboards and all this stuff. They monitor dashboards in the SIM tool. in their particular SIM. They're going to be talking about what the SIM tool is, different type of SIM tool, and all this stuff. So SIM dashboard display alert and suspicious activity continuously. Continuously, they're going to be alerts. Some are real, or some are true positive, some are false positive. Alerts are just going to be keep popping, keep popping, keep popping. So you're just going to be keep monitoring dashboard. If there's any alert that's been assigned to you as a SOC analyst, then you know go on as we talked about in the previous slide. So triage alert is you basically doing some little investigation, right? Just determine true positive or false positive, severity level, and all this stuff. So that's you basically triaging the alert. Then number three, we have investigate. You're going to check the logs, check IPs, check the user that's been involved, check the activity that has to do with that particular alert, check that particular network traffic that has to do with the time duration of that particular alert, and then authentication history, right? Then escalate or contain, right? It's either the SOC analyst escalates the attack, or he contains. If it's a tier three SOC analyst, he contains the attack, write his reports, and forward to the SOC manager, something like that. So either he contains, maybe disable the account if it's maybe someone's attacked that account that's been, or a particular user that's been affected. Then you need to disable the account, or this tier three, so sorry, level 3 SOC analyst actually needs to disable the account in order to make sure it doesn't affect or spread over the entire network, something like that, right? Block IP, the particular IP that's actually bringing in the outbound traffic, or that's trying to that's trying to attack, and then isolate that particular host, and then escalate to level 2 or level 3 if it's a level 1 SOC analyst. I also want you guys to understand something. Sorry, not every company actually follows this level 1, level 2, level 3 thing. In some companies, you might be given a job as a SOC analyst, but you're going to be doing the job for tier 1 SOC analyst, tier 2 SOC analyst, and also tier 3 SOC analyst. So that's basically it. Just depends on actually the only company that actually follow these standards are actually like um big tech companies, actually, like, no, not only tech companies, like big companies, like not small companies, but most medium-sized enterprises just hire like one, not one person. But if you're a SOC analyst, you are going to be working as a level 1, level 2, level 3. You don't have a specific role. It depends on the alerts that's coming in, the attacks, and all this stuff, right? Understanding alerts. So let's understand the type of alerts we have. Why SOC team miss attacks, right? Let's quickly brush through this. I've been saying true positive, false positive, false negative, and all this stuff. So let's quickly talk about them, what they mean, and why it's important in the SOC. So a true positive is like a real malicious activity correctly detected. When an alert is flagged as true positive, it's a malicious activity that's actually malicious, or it's an attack that's actually an attack coming from a real attacker. That's a true positive, which could actually be a potential or a danger to that particular organization. That's a true positive. An example is 10 failed logins followed by a successful login. Right? This is just an example. Maybe after 10 failed login attempts, then there's one successful login attempt. That's actually suspicious. Right? Maybe the attacker was trying to guess the password. So he guessed 10 times, he wasn't successful, and then maybe the 11th time he was successful. So that's basically a true positive. This is just like a simple example. Then we have a false positive. Activities incorrectly flagged as malicious. Stuff that are not actually malicious, then the system flag them as malicious, or it pops up an alert, but it's actually not malicious, or it's actually not an attack. Maybe it's just a user or someone in the organization or in the network trying to do something, right? And we have an example: administrator logged in repeatedly. Let's say, for example, an administrator tried to log into his system. Let's say, for example, he forgot that the caps lock was on, and maybe the password was ABCD, and then he typed in ABCD. And let's say the system is not case sensitive. What we mean by case sensitive is that um let's say A in capital letter, the system reads A in capital letter very different from A in small letter. That's case sensitive. So let's say, for example, he forgot that caps lock was on, and then he typed in ABCD in capital letter instead of typing ABCD in small letter, right? So obviously it's going to say incorrect password. Maybe the administrator will not realize. Okay, he's going to be like, "Ah, what just happened?" He's going to try to type it again, ABCD failed, ABCD failed, and then the system might flag it, okay, as an attacker trying to guess the password or trying to run a brute force attack in that particular system, but it was just the administrator, being naughty and foolish. I don't know what to call it. Sorry for that. So that's basically that. I just hope you guys understand. And then we have false negative. This is not actually common. The most common, scenarios we have is true positive and false positive, right? Then false negative is a real attack missed, right? And this was one of the example, one of the effects of alert fatigue. Let's say we have 1,000 alerts and we have 5 SOC analysts, 1,000 alerts in a day, and we have 5 SOC analysts. So obviously, there's no way those 5 SOC analysts can attend to each alert, right? So maybe they missed an attack for a particular amount of time, and then that time that he missed the attack actually gave the attacker chance to do whatever it is he wants to do, gain access to the system, steal some information, and whatever it is he wants to do. That's a false negative, right? They missed the attack at the alert completely, and it happens actually. Yeah. Then we have an example: malware bypass detection rule, right? Let's say, for example, the attacker is trying to send in a malware, but the malware bypass detection rule, it was not even detected in the first place. It was not even detected or flagged, and that's one of the reasons why level 3 SOC analyst actually does threat hunting. They just check the logs for any suspicious behavior or suspicious stuff, because some stuff might actually bypass the alerts, because hackers are also smart, right? So that's basically it. Let's talk about alert fatigue. I know I'm just you know putting in a lot of theory in you guys, but I think from this slide we have sim tools. We're going to start doing some low practical. So, and we have just like 5 minutes. So I think we're going to add extra time. I'm very sorry for that. Let's just try to round up whatever it is we are doing. So we have alert fatigue. One of the biggest problems in SOC, or the Security Operations Center, and what it causes actually. First of all, important alerts get ignored. Analysts become exhausted, detection quality drops, and real attacks are missed. So what's alert fatigue? Let's say, for example, you have 1,000 alerts, and out of that 1,000 alerts, let's say 700 of those alerts actually false positive, meaning they are not actually real cyber attacks. So what do you expect? The analysts are going to be exhausted. Maybe the next alert they're going to be checking, they'll be like, this also another false positive. Let me just quickly, sharply just do this anyhow, and just move on to the next one. Something like that, right? So that's basically alert fatigue. So, and there's a way to reduce this alert fatigue by creating stronger detection rules. So they don't detect stuff, or they don't shoot out alert that are not actually real attacks, right? That are not actually suspicious. So that's alert fatigue. And then we have a reality section. So some SOCs receive thousands of alerts daily. Only a small percentage are truly malicious or suspicious, or only small percentage of that particular alert are actually from attackers. Some are just maybe someone tried forget his password, or one of the employees was doing something he was not supposed to do in the network, maybe browsing a site he's not supposed to, maybe accessing the dark web using the company's Wi-Fi or something like that. Because sorry, not every employee knows that they are being monitored because of security purposes. So defender takeaway: good detection engineering matters more than having many alerts, right? Detection engineering, as I told you guys, just writing detection rules in order to trigger alerts, right? So let's quickly move on. So introduction to SIM. What a SIM tool? The full meaning of SIM is Security Information and Event Management. A SIM tool is the heart of SOC, right? It's where MC it's where 70% of security operations center actually goes on, or it's where 70% of SOC analysts do their thing. So a SIM tool is used to collect logs from systems or endpoints or different sources, or just different systems from the company, right, or organization, or whatever it is the SOC is being set up. It's used to also normalize and store logs. It normalizes and also store that particular log is being collected, or it collects actually, and then it correlates events. You can use a SIM tool to correlate events, meaning you can search through those logs using a SIM tool. And then you can use a SIM tool to detect suspicious behaviors, which is one thing that's also very, very important, or one thing that's used a lot in SIM tools. And then you can use a SIM tool to generate alerts. To generate this particular alert we have been talking about, you can use a SIM tool to actually do that. And then it provides dashboards for analysts to visualize whatever it is they are doing. Right, a dashboard is used to visualize what analysts are doing. So just think of it as a Google search for security logs. It's just like it's Google, like you go to Google and search for something now, when you're looking for something. So that's basically it. A SIM tool is a place, or you can just see it as a Google search for security logs, right? One platform, all logs, and real-time detection. It's also been used for real-time detection, right? let's talk about how SIM architecture works. So after this slide, I want to show you guys. After the next slide, we're going to be talking about different type of SIM platforms or SIM tools we have, and then we're going to, go on one of that particular SIM tool, and then try to see how it works and do some stuff on it, right? So from logs to detection, how does it actually work, right? So first is data sources. Data sources can be Windows, Linux, firewalls, IDS, IPS, cloud applications, whatever it is, it can be, as long as it's digitals and it's everything digital actually has logs. I wanted to say as long as it's digital and it produces logs, but everything digital produces logs. What are logs? I want to talk about. We're going to be talking about that. Logs are actually just your footprint on, like your digital footprint, right? That's actually log. So data sources. This data source actually is talking about where the logs are coming from. The log can come from a Windows computer, a Linux, firewall, IDS, which is intrusion detection system, IPS, intrusion prevention system, the cloud, and also applications, a lot of applications, right? Then log collection. So first one is data sources. You need to connect your data sources, or you need to set where the SIM tool will actually have or receive data from. And then log collection, how the log is going to be transferred from that particular endpoint or data source to your SIM tool. It can be agents, maybe through agent, it can be through syslog or that system log or APIs. Right? Some SIM tools actually support APIs, while some don't support APIs. Right? It can also be through local files. I did not add that here, and which is one of the ways you're going to be using in order to collect log in this particular class. It can be through local files. Then three, pass and normalize. So different logs converted to a searchable format. Passing the logs is actually you sending the logs to or collecting the logs to the SIM platform and normalizing or setting them up so you can be able to search through it and do an investigation. So that's basically passing and normalizing logs. Then correlation rules. You can create rules. If X plus Y happens together, then generate alert. So this like the logic that's being used while generating alert. You can say, okay, if one particular IP address failed to log in, or if any IP address at all in the network failed to log in, let's say 5 times, then just generate an alert or send me an alert. Okay, just send me an alert or generate an alert. That's basically one of the things SIM to or how the SIM architecture actually works. Then dashboard and alerts displayed to analysts in real time. Alerts actually displayed to analysts in real time, depends on how the setting is. It can be sent through email, it can be sent through a ticketing system, can be sent through Slack and even WhatsApp or even SMS, depending on how you set it up, right? But in most cases, professional settings, it's just being displayed in a ticketing system or emails. It's being sent directly to analyst emails, something like that. So common SIM platforms. Let's quickly talk about some commonly used SIM platforms. We have a lot of SIM platforms, but let's talk about the most common ones or the ones that are actually used a lot. First one, we have Splunk. For me personally, I like Splunk. I believe it's the best SIM tool ever, right? First one, we have Splunk. Splunk is very powerful. It has powerful search capabilities. It's also very flexible, and also it uses SPL queries. Yeah, and yeah, when I say you can search through logs, it's not that you just go to your search bar and be like, um, tell me when this particular user logged in or something like that. No, they're going to be using SPL queries, which is Splunk Processing Language Queries, right? That's the full meaning of SPL queries. Splunk Processing Language Queries, right? It uses SPL queries. It's widely used in enterprise SOCs. I think the last time I checked, 70% of big enterprise or large enterprise actually uses SIM Splunk as their SIM platform, right? And then Microsoft Sentinel. Microsoft Sentinel is a SIM tool by Microsoft. It's cloud native. That means it only works in the cloud. It doesn't have like an on-site application or something like that. It's a cloud native platform. Microsoft Sentinel. It integrates with Microsoft ecosystem. It does not actually only integrate with Microsoft ecosystem. It integrates with a lot of stuff, even not Microsoft products or ecosystem, but mostly it integrates with Microsoft ecosystem. And most of the companies, organization that uses Sentinel, organization that actually uses a lot of Microsoft products because it's more easier to set up and all this stuff. So it's popular in Azure environment. Obviously, it's being used in Azure environment, right? So it's very popular when it comes to Azure environment. Companies that have a cloud platform, especially with Azure, it normally go with Microsoft Sentinel. Depends on their SOC analyst or their SOC team or what they decide to go with. But most of them decide to go with Microsoft Sentinel. And then we have IBM Curator, enterprise focus SIEM. IBM Curator, obviously it's a SIEM tool by IBM, right? I believe you guys already know the IBM company. It's an enterprise focused SIEM. It has strong correlation engine, right? Meaning it has a strong search engine. Let me just say it that we just look at it as a Google. We have different search engines like Google, Yahoo, and all this stuff. So just look at this as the best search engine for SOC or for logs, right? Strong correlation engine, large scale deployment, meaning IBM Curator is a SIEM platform that's actually very good for large scale deployment. If you are looking to expand your SOC, or if you are looking to install a very large SOC, or large scale something, large scale SOC, you should go for IBM Curator depending on your team and a lot of factors, but it's actually very good for large scale deployment. Yeah. So every SIEM work differently, but the SOC analyst work remains similar. All of them, whether Splunk, Microsoft Sentinel, IBM Curator, they have the way they work, but their work is the same, just to correlate logs, create some alerts, fire some alerts, do some investigation. The works are the same, or what they do actually the same. And there are a lot of actually SIEM tools such as Wazoo, Elasticsearch, no, sorry, ELK stack, um sorry, yeah, a lot actually. I won't forget the name of some. Yeah, a lot of SIM tools, but these are the most used in large organizations. These are the most used. Some are free, while some are not free, while some have some free versions and a paid version. So let's quickly talk about the SOC. Let's quickly talk about the particular SOC. Sorry, SIM tool we have. So I'm just trying to escape from this. I don't know why it's not escaping. I want to exit the slide. Right, yeah. So this is Splunk, which is what we are going to be using for today. So as you can see, I already have it installed. Let me quickly walk you guys through the process of installing it. I know we don't have much time, but let me quickly walk you guys through the process of installing it. So first time, if you want to install Splunk, right, all you need to do is go to your browser and just type in Splunk. Just type in Splunk to bring you to this page. So click on the official website. Just go into the official website, and yeah, I'm just gonna do that. So it's very important you guys download this so you can practice, and you can, if you don't have an account, you sign up, or if you have an account, you log in. You can't download the application without signing up or logging to their platform. So let me quickly log in. Yeah, if you have questions, just write them down and maybe send them to the group. So I don't think we should be answering questions. So I already have an account, although it's not my real email, but I have an account. So let me just quickly log in. Still loading. Yeah. Let me quickly show you that. Yes, I think I'm logged in right now. I'm authenticated. So all you need is just to go or help to try and download page. Scroll to down. As you can see, we have different types of Splunk. Depending on how you want to install it, you can install it in the cloud Splunk cloud platform. They also have a cloud, um, a cloud package. Then Splunk Enterprise, which is the one I'm going to be using actually. Splunk Enterprise. Then click on Start Free Trial, because as I told you guys, this is paid, but you can actually use a free trial. It allows you to upload 500 MB of logs per day, and I think it expires after I think it's a month or something like that. So you just need to uninstall it and install it again, and it's back. If you're using a Windows, if you're using Linux, you can also download. If you're using Linux, I will advise you just go download this .deb or dev file. You can just download it. It's more easier to install. You can just download this. This is a zip file. You can just also download it and install this. And if you're using a Mac OS, you can also go with it. This is a zip file. Yeah, I'm not really familiar with Mac OS, but I'm sure this is a zip file. You can just download it and install it. But in Windows, all you need to do is just to click on download. When you click on download, it should start downloading. No, it should start downloading. Supposed to start downloading actually. After it's been downloaded, you need to just go through the installation process. The installation process is actually quite simple. I don't want to walk through it because we have limited time. So let's just quickly continue. Right. So basically, after you are done installing it and everything works perfectly, you can just quickly go to your maybe local IP address and then this 8,000 ports, which is the ports Splunk runs on, and then click on sign in. This is my username. I have my password. Yes, I was trying to do some stuff. You know why it's not showing? What? I don't know why I can't click on the page. So allow me to click on the page. Let me just quickly open it and all that. And that's I don't know why my blog installation have not started yet, but that's just the process of how you can start down or how you can use your Splunk or how you can download Splunk actually from the website. The installation process is actually quite easy, and I believe it's something you guys can actually do on your own. Then we have search and report, which is what we're going to be using as SOC analyst in Splunk. There's a lot of things actually we need to cover in Splunk. I know you guys have a lot of questions, but as Mr. Victor said, we are trying to compress what we are supposed to do in like 3 months into just 1 month. So I'm going to try to, be as quick as possible. So let's quickly go back to our slides. So let's finish that before we come back to our sim tool, right? Well, we are still on slide 12. I'm going to be very fast right now so we can just do some practice. I know you guys are already bored, but let me just quickly wrap things up so we can just do some practice. I think I already spoke about this. All right, let's talk about correlation rules. How correlation rules actually like detection rules, how these alerts are being done or how they are being created, right? How SIMs detect attacks. Let's say for example, this is a brute force detection, this is a brute force detection, right? This is just like a logical something. We can be like, okay, our second analysis be like, but using SPL code is actually just an example. Like if 10 field logins within 2 minutes, if there's a field login attempt within 2 minutes, you can see from the same IP address or whatever it is, if there's just field logins within 2 minutes, then generate a brute force alert. Then you can say, okay, generate an alert named brute force. So whenever there's someone who tries to log in and it fails 10 times within 2 minutes, then it will generate an alert or it will pop up or it will send to something like, yeah, an alert is being generated, a brute force alert is being generated, right? So that's basically it. So impossible travel. Let's say, for example, there's no way someone can just travel from Nigeria to maybe the US within 2 hours or 3 hours or 4 hours. It's not possible, right? So if user logs in from Nigeria and 5 minutes later from Germany, 5 minutes, it's nowhere close to possible. Obviously, then in this case, it's a VPN or it's someone trying to log in using the persons who like, let's say for example, okay, it says logs in from Nigeria and 5 minutes later from Germany. So let's say for example, the employer is from Nigeria and then the attacker or the hacker is from Germany. So he gets the credential of this particular Nigerian person and then tries to log into his account 5 minutes later from Germany, after 5 minutes later after the Nigerian login into his account. So obviously it's not possible. So maybe someone's trying to log in. So if user logs in from Nigeria and 5 minutes later from Germany, then generate impossible time travel alerts. That's basically the logic behind this. So soon as port scanning, one IP targets many ports quickly, then generates scanning alerts. So that's it. So what are actually logs for? what are these logs for? Or what are even logs, right? Logs are actually digital footprint of every single action. Whatever you do on your laptop, your system, on the network, this is logs or it's being recorded. So login attempt, file access, process execution, firewall activity, DNS request, yeah, even DNS traffic or your web traffic is being logged. PowerShell commands, a log actually is just like some important, right? Logs are evidence. Without logs, investigation becomes guesswork. You're just to be guessing because but logs don't lie. Actually, logs don't lie. So that's basically it. So we have different types of logs. So let's first one we have Windows event logs. Logs every SOC analyst must know. Windows event logs actually. These are some Windows event logs that we have. We have the event ID and also we have the meaning of them. Also, we have 4624. Whenever you see this particular event ID in a log, it means there was a successful login, right? So, yeah, when you see a log file, it will not just tell you, okay, this is a successful login, this is a failed login, this is a process creation, this is a user account. No, actually, if it's a Windows logs, it will just give you this event ID. So, from this event ID, will know what type of log was it, or what type of activity actually led to that particular log. Then if it's a 4624, that's a successful login. 4625, 4688, the process creation, and then 4720, a user account created, like a new user was created, right? And 4672, admin privileges assigned. Maybe it's an attacker who assigned himself the privileges of an admin, or a person who's privileged in that particular system or environment. Let me quickly show you guys where you can find your Windows event log. So you can actually check the logs if you're in Windows. You can just go on to event viewer. Just open your search bar and head on to event viewer. Let's just try to look for one of these event IDs and see how it's been how we can view it in our Windows. So actually this some events, recent view notes, blah. Okay, this is the log summary. Logs. Let's look for a log that's actually simple. Let's see Windows logs. You can click on application logs. As I told you guys, there are different sources of logs. We have application logs, security logs, firewall logs, a lot. So it's loading actually. That's why we have number of events, 13,000 events, because we have 13,000 events. Let's see Microsoft. Let's click on this and see. As you can see, this is the event ID. The description for event ID 2562 from source Microsoft Windows app, blah, optional cannot be found either. So it can't be found. So this is basically the event ID. So this event ID is what you're going to be using to identify what type of process this is. So from this, we don't know what process this. You can just simply copy this and search on Google, like, okay, what process has this particular event ID? Then you will know when this process is being executed. So as you can see, this is actually very, very sophisticated and hard. Let's say you want to look or you want to check if there's a malware in your laptop. There's no way you're scrolling through or you're checking this one by one. If there's any suspicious or uncompleted suspicious behavior. So you can't just be checking this one by one by one by one. So that's why these logs are being forwarded to a SIM tool where you can correlate and search through these events, right? Easily actually. So you can see we have different type of logs, and every single log have its own event ID. You can see we have you can see this is the event ID, this is tax one. I can't see the full meaning, but let's see. So this is the tax category, non event ID 000. Let's see. Let's go up. So you have different event IDs. So these event IDs are going to determine what type of events these are. So that's basically this what these event IDs are actually all about. Okay, finish loading. Yeah. So let's talk about what analysts look for in this particular, or most things analysts look for. First of all, most times analysts look for multiple field logins because you can't just be searching through everything. You have to have something you're looking for. Most of the times, hackers or SOC analysts look for multiple field logins. Sorry, it's not. Yeah, so new admin account created. If there's any new admin account created, suspicious PowerShell execution, is there anything? Because if it's a malware, obviously a malware has to do with PowerShell because it has to execute some stuff. So suspicious PowerShell execution, unusual login times, and so on and so forth. A lot. So we have also Linux logs because every single operating system and systems or log sources have their own way of storing their logs and So let's understand Linux logs, or how the structure of Linux logs. So Linux saved its logs in this particular folder, var/log/auth.log. Let's quickly check that. So I have a Linux instance running, although it's not the Linux you guys know in VirtualBox. This WPR, sorry, WLS, WLS or something like that. So I think it's a new technology that allows you to integrate Linux directly, or install Linux directly into Windows. Yeah, so that's what I'm currently doing. I'm running Linux directly into my Windows, or my Windows. So that's basically, so as you can see, it's being saved in the VAR, or variable log authenticate, or slash authentication, blah blah. That's the authentication log. But under the log folder, there are a lot of logs. Let's try to go there. You can say cd var slash um logs slash what. Let's see. Okay, cd var slash, let's try to see. Okay, it's just log. I added an s. So as you can see, we have different type of logs, alternatives.logs, Apache 2. There's a particular server we call Apache 2 server. So whatever logs has to be that particular Apache 2 server, it's here. APT logs. APT is when an app is being installed and uninstalled in Linux. We have authentication logs. If a person authenticates, we have not just one authentication logs, 1, 2, 3, 4, 5, all this stuff. We have bootstrap.log, btmp.log, cronjob.log, sorry, just cron job, and then dpkg, which is a manual install. We have a lot of logs. As I said, every single thing you do has its logs. As you can see, I have Wazoo installed. Wazoo is also a same tool. That's Wazoo install logs. The installation I did for Wazoo, it also logged that in. It's a log, right? Wazoo password tool.log, blah. See, we have different types of logs. So this basically where Linux stores its own particular logs, or its logs. So when you want to, it's very important for you to know this, because when you want to send these logs to your SIM tool, you need to know where it's been located in order to just send them to your SIM tool to correlate and do your investigation. Yeah. So as we have different logs. Understand, you have authentication log, sys log is the system logs. The time the system was turned on, the time it was shut down, and all those stuff actually are being logged. You have SSH logs. SSH is secure shell. Sudo logs, which is a super user do logs. Just a super user logs. I don't want to go into much explanation. Then SOC analyst actually worked for field SSH logins. This for Linux log, right? Privilege escalation attempt, new user creation, suspicious sudo usage, and a lot more of stuff. Example logs. This is like an example of logs. A field password for root from this particular IP address. This is just like a one-liner log, just to give you an idea of how the logs are being displayed, right? This could be a possible brute force attempt, failed login from root user, this particular user. But we can't say it's a brute force because it's only like one line, so, or one time. Oh, sorry. This is just like an example. It can be so monitor source IP, check frequency, and cross-reference firewall log. A lot of logs. There are a lot of log sources, log types, but we don't have much time to talk about all of those stuff. So let's quickly dive into firewall logs. So monitoring network traffic, actually, firewall logs, all the logs that has to do with firewall, you're going to be using them to monitor network traffic, right? Source IP, destination IP, port numbers, allowed or blocked traffic, protocols used, and a lot more, right? What analysts look for in firewall logs: connections to malicious IPs, large outbound transfers, maybe transferring something or something going out from the network, in a large amount of numbers or something like that. We have port scanning activities, traffic to unusual countries or locations, right? We have authentication logs. Obviously, I believe you guys already know what authentication logs is, right? Tracking user access, login attempts, MFA, which is multi-factor authentication failures, password resets, account lockouts, and much more, and even successful login, all this stuff, right? Then why they matter? Many attacks begin with compromised credentials, as we saw in the 2021 colonial pipeline attack in the American oil pipeline, right? It began, or it was, the attacks were able to achieve that with a compromised credentials, right? So that's one of the reasons why authentication logs are very, very important. Common indicators: multiple failed logins, logging from unusual locations, logging outside business hours, right, or office hours. connecting networking to SOC. Right, let's quickly talk about why networking knowledge is very, very important for you as a SOC analyst. We have been talking about IP address, we've been talking about port numbers, we've been talking about traffics, network traffics. So that's why it's very, very important for you as a SOC analyst to have networking knowledge. If you don't even have networking knowledge, you're not actually a SOC analyst, right? So you're going to be dealing with IP addresses, ports, protocols, DNS activities, network flows, a lot of things that has to do with network packets, network traffic, network logs, just network. So it's very important for you as SOC analyst to know networking. You cannot investigate attacks properly without networking knowledge. There's no way you can. There are a lot of things you will not even understand. Common ports. We have some common ports. Although I know Mr. Victor already taught you guys about networking basics. So in your last class or in the first class, which is on Monday, or which was on Monday, right? So let's quickly just go through this. We have port 22, which is SSH logs. These are like common logs you are going to be seeing as SOC analysts in your logs. You have port 22, which is SSH logs. Port 3389, which is RDP log, which is remote desktop protocol, right? You have port 80, which is HTTP log. We have port 443, which is HTTPS. HTTP is hypertext transfer protocol, while HTTPS hypertext transfer protocol secure, which is the most secure version of HTTP, right? Common network-based in detections, right? Suspicious patterns analysts look for when it comes to network. The first one is port scanning. One IP address targeting many ports quickly or at the same time. We have brute force traffic. Sorry, I'm too fast. We don't have enough time. Brute force traffic, repeated authentication attempts from same source. We have lateral movement, attackers moving between systems internally, moving from one system to another, right? Data exfiltration, large outbound traffic leaving the network, large amount of data or unusual data leaving that particular network. That's data exfiltration, obviously. Then we have DNS tunneling, using DNS traffic to hide malicious communication. These are all types of cyber attacks, right? So, up to now, we have not get to this scenario, but I personally, I want us to get to the practical part of stuff because this is just boring. Also, but just bear with me, guys. We are soon. We will soon be there, right? Firewalls, IDS, and also IPS. Obviously, you already know what a firewall is. IDS, intrusion detection system, and then IPS, intrusion prevention system. Understanding the difference. Let's understand the difference. So a firewall controls traffic. It allows block connections based on rules. So you also set for a firewall rule to allow maybe some particular amount of traffic into the network and allow some particular amount of traffic or packets out of the network. So that's basically a firewall. And then we have IDS, which is intrusion detection system. It detects suspicious activity, generates only, does not block, it does not do anything. All it does is just to detect suspicious activity and then alerts you when there's anything, or when it detects or when it thinks anything is suspicious. And then we have IPS, intrusion prevention system. It detects and actively blocks attacks in real time. It does not only detect, it also blocks alerts or attacks in real time, or what it thinks is an alert, or sorry, an attack in real time. That's basically. I hope you guys actually understand that. So let's quickly talk about MITRE ATT&CK framework. The framework SOC team use worldwide. Every single SOC analyst knows MITRE ATT&CK framework. So MITRE ATT&CK framework is a framework that categorizes attacker behavior. You have different types of attacker behavior. And one thing you should actually know as SOC analyst is that attacker behavior never changes. Attack never change their techniques. What they change only is tools. They never change their techniques or behaviors. They only change their tools. um MITRE ATT&CK helps with structured detection, understand attack chains. It helps understanding attack chains, right? Like what attackers, like the workflow attackers go through before launching an attack. It improves investigations. It also helps in building detection rules or quality detection rules in order to avoid alert fatigue, as we talked about. So these are some of the stuff in the MITRE ATT&CK framework. Or sorry, something just came up. So these are some of the things you need to know in the MITRE ATT&CK framework. These are some of the patterns or behaviors in the MITRE ATT&CK framework. First one, we have initial access, which is attackers gaining access to a particular system or particular network. We have execution, right? Them executing whatever it is they are, they gained access to do, whether it's stealing money, data, whatever it is, execution. Then persistent, looking for ways to be persistent in that particular network so they can easily gain access next time they want to do whatever it is want to do. We have privilege escalation, trying to go from a non-privileged user to a privileged user, maybe from normal user to an administrator or from a normal user to a root user. The literal movement, trying to move from one system to another, or from one server to another, or from one network to another in a particular organization. And then we have exfiltration, which is exfiltrating data, or whatever it is they're exfiltrating, right? So these are the phases, or phases, or this is the MITRE attack framework, right? And yeah, the MITRE attack framework, can just simply head on to MITRE attack framework so that in order to learn more about the MITRE attack. Here's the MITRE attack framework. It's very important because every single alert or every single incident you're going to be working on as a SOC analyst, you need to map it to the MITRE attack before you even, submit it. Otherwise, before you have initial access. Under initial access, we have 11 techniques, which is the techniques actually hackers use when trying to perform initial access. And then under execution, we have 20 techniques, which is we have 20 techniques hackers actually, use when trying to, execute the right things, executing persistent, previous escalations. We have a lot. You can just go through my attack. I don't have like you know, the time we have will not allow me to actually explain a lot about my attack, but it's very important you guys go through my attack. It's something like every single SOC analyst should know, right? My attack is actually very, very important. So we have a defender takeaway. My attack helps analysts pick a common language across teams, and mapping attacks to MITRE, you can just map some attacks. So brute force login, we can see okay, brute force attack can fall under the, or brute force technique can fall under the category of T1110, I think, which is initial access. So as you can see, if you go back to the MITRE attack site, I'm not teaching you guys how you can map it. No, this is not T11, TA. The initial access is TA001. No, there's not a TA002 T. No, no, no. So basically, this is how you can map. Because you can't just start looking for. You can just start checking for which one is T11. This. So basically, so that's it, right? Yeah. So brute force T111. Blah blah. You can just check. Okay, under which category does this particular MITRE attack framework, is this T111? If you have been asked to map a particular attack to a MITRE attack framework, this is what they're asking you to do. Just bring out this number or this code actually, right? So yeah, we have PowerShell abuse T1059. This is like the number or the code for that particular technique under the MITRE attack framework. Right, you have credential dump, which is this number, remote access, remote service, this is phishing attachment and all, right? Yeah, so finally, let's quickly do some hands-on investigation, right? In a real life scenario, or with a scenario I just created, right? So your first SOC investigation, I want you guys to screenshot this before we continue. Or even if it's just one person, you can just screenshot this and send it to the group, because this also, you guys are also going to be doing this. I'm going to be sending you the log file you guys are going to be using to do this. And yeah, you're going to be doing some research on yourself, right? Or maybe after the class. So, hands-on investigation scenario. The senior an employee reports suspicious activity, account activity. The SOC receives several authentication alerts overnight. Maybe an employee it's like, okay, maybe something has been happening to his laptop, or a particular account he's using that he finds to be suspicious, and then reports to the SOC analyst. Then the SOC analyst received several authentication alerts overnight, right? Meaning, okay, something has been happening overnight while they were at home or something like that. Although there are SOC analysts in night shift, but let's just leave it like this. So our job, or my job, is to identify suspicious behavior on the logs, determine if a compromise actually occurred, find the attacker IP address, and then recommend next step for the SOC. Let's quickly do this, right? So first on, since I don't have like any log source, I'm not receiving log from an endpoint, maybe a Windows, a firewall, and all this stuff. Or what I can do is that I already have a log file that contains whatever log I have that can, give me the result I need for this particular task. So if I want to upload a log file, or let's say you have been handed log file, maybe your SOC manager gave you this log file in order to do this investigation, or gave you this log file and then gave you that particular task. All you need to do is head on to settings in Splunk, right? You can just simply it's somewhat similar, like if you know how to use one particular SIM tool. The rest is actually quite easy, right? So you can just head up to settings, then forward and receiving. Oh, sorry, data input. It's supposed to go into data input. So let's quickly run this up. Oh, I don't know why is this taking time. Oh, yeah, so let's just have a reaction so I will know you guys are actually with me and understanding what I'm doing. All right, thank you very much for that. Yeah, we have our SIM tool and we have this data input. So we want to upload our log file, which I'm going to be using to do our investigation. This is the so first of all, as I'm going to go to the settings and click on data input. So after you click on data input, this is where it's going to bring you, or this is what it's going to be showing you, and then you choose local event collection, remote events, files and directory. Obviously, files and directory because we're going to be uploading the file. Then all you need to do is just click add new, add new. And I said it doesn't matter which SIM tool you use. All that matters is what you do, right? As a SOC analyst. Then file directory. Then you need to browse. I already have a log file. It's located in my desktop. So let's go to users. You just need to locate where you store. Obviously, you should know where the log file is being stored. Then what's the name? What's the name? Yeah, this is it. Timestamp log, and yeah, this was just this is what I chose to name it, timestamp log, source event, and all this stuff. As you can see, this is it. So you can choose to continue. You can choose to for it to continuously monitor or just index once. What it means by index once is that okay, it will just just operate once and do your searches, and when you turn off your Splunk or when you restart your system, the log is gone. You need to upload the file again if you want to do anything with that file. But if you choose continuously monitor, whenever you turn off your system or whenever you add something new to that particular file, automatically it's being sent to your SIM tool, right? So continuous monitor, right? Let's just leave it as continuous monitor because we might be using the same file for our next class to do more investigations. Our next class is going to be more of practical aspect. I don't think I want to even do a slide that's more than 5, so we don't waste much time there. Because okay, this how the logs is being shown, or this how the logs is. So it's going to show us here, so we can preview it before we even proceed, right? This is the source type CSV, and then yeah, everything is good. Next. So you can just quickly, you know, check up some settings, app context, search and reporting. This is basically the app you're going to be using, search and reporting. You can make more research, or you can just slide into my DM and ask me whatever question you want to ask. So this Splunk has different apps. As I said, Splunk on its own is something will take a long time explaining. So let's just quickly wrap it up. So search and reporting, constant value, and then the host field, which is the desktop. This is the host. You can just quickly change it. Let's say host. Let's leave it as employee. Employee. Let's just leave it as employee. Then index. You can choose an index. Oh, index. I'm also supposed to. Index is basically where the logs are being stored. You can create an index. Let's say an index is employee. So basically, this log is being stored in employee. If you want to upload another log file, you can upload another log file and store it in employee, or you can create another index. Let's, for example, all the employee in that particular organization are stored under this index named employee, and then all the oh no, let me just say play. Okay, all the IT professional in that company is stored in an index named IT professional. I'm just giving an example, and then the rest of all the HR employees in that particular organization is stored, or their logs, or the logs coming from that all the HR computers in that particular organization is stored in an index called HR index. It's more easier, it gives you more flexibility, you know, well, when searching or when an incident happens, it does give you more flexibility over your logs, right? And yes, so we are done actually. So you can just review whatever it is you did. Input type, file monitor. Yeah, you want to be monitoring the file. Source path. This is the source path where the file is being saved. let's say, for example, you are receiving this log from another operating system or another endpoint. You can see maybe Windows or the name of the user in which you are accepting logs or collecting logs from. Continuously monitor, yes, we want to continuously monitor this particular file. Then source type CSV, so CSV file, which is comma separated value. That's the full meaning of CSV. Then app context search, which is the app I'm going to be using to open this particular log file. Host employee, which is the name of the host, or the name we decide to put for the host, right? And then index employee. The reason why I I was asked to name this is because we are not receiving the logs directly from an endpoint. If this we are receiving the logs directly from an endpoint, it will show you the username of that particular endpoint. You don't need to add the name of the host. Right, so we are done uploading our stuff, so we can just start searching. So let's wait for it. Yeah, so as you can see, we have our logs. So this is how the logs is being displayed. We have lots and lots of logs. You can see it's a lot of pages, not just one page, right? So you might be thinking, okay, where should we even start from? But before we even start, let's take a look at our scenario. No, where's the let's take a look at our scenario. So the scenario hands-on investigation scenario. So it is an employee reports suspicious activity and account activity, right? And then the SOC team received several authentication alerts overnight. This is our job. Our job is to first of all identify behavior in the logs or suspicious behaviors in the logs. If there's any suspicious behavior or something we think is suspicious in the logs, we need to identify it and then determine if a compromise occurred, if it's actually a compromise or it's just maybe an administrator trying to log into his computer. Maybe one or two times he failed, and then later on he was able to log in or remembered password or something like that. And then find the attacker IP address, the person who's really logging that it failed, or the person who's trying to do whatever suspicious activity he is doing. You need to find his IP address and then recommend next steps. Right. So we're going to be acting as a tier one SOC analyst. Obviously, we're going to be acting as a tier one SOC analyst. So let me quickly go back to my sim tool and yeah. So personally for me, before I start, the first thing I do, okay, what's the investigation goal? The investigation goal is to identify suspicious behavior. And then after that, what? Determine if a compromised attack, find the IP address, and then report, oh no, recommend next step. Then we have some data fields. So what I mean by field is like this host now is a field. This time is a field. As I see, every single event has its own time that it's called IDS. This log events from IDS, IPS. So what I did is that I compiled a lot of log sources, logs from IDS, IPS, Windows, Linux, firewall. As you can see, this is one the firewall log. This is the time firewall log, blah blah. 443. This is like a web traffic, right? I'm just showing you guys like this is the IP address. This IP address, I think this IP address is the one requested from this IP address using no, this is not the port number. I'm not sure what this is. Then this is the port number, which is the HTTPS, right? Then it's using the TCP protocol, which is the time. Oh my god, TCP. I'm forgetting the full meaning of TCP. Just pardon me for that, but also has a TCP. And then we have C2 beaconing. See, just from this, C2 means command and control, right? C2 beacon. This is something malicious, but that's not why. Yeah, and yeah, that's not part of our tax, but that's just we also have another C2 beacon pattern detected. C2 beacon pattern detected. 15-minute interval to blah blah. So this also some attacks or suspicious stuff you can check, but that's not what you're here for. That's not our attacks. So first one, we don't need all of this. We don't need this. Nah. It's no, we don't need all of this. Let's just remove all of this. Let's search. So this is our search bar where we are going to be searching through our logs. So what we need to do is index, right? If you guys don't forget, we did not forget we created an index. The name for our index was employee, if I'm not wrong. Yes, so as you can see, they won't autocorrect employee. Whenever you click, if you click enter, whatever logs that are in this employee will show. So as I can see, as I told you guys, index is actually where your logs is being stored. Employee, you can create another index with a different name, just to categorize them. So it shows all the events under this employee, right? So first on, let's load authentication. Let's see, no, source type. Source type meaning like the type of event we want to see. You can choose authentication logs. The reason why I'm not choosing authentication logs is because we are not retrieving this from my endpoint. So obviously, I don't know if it will categorize this somewhere as an authentication log, right? That's why. So first on, what is the goal or what is our first task? The first task is identify suspicious behavior in logs. So let's use a logic in order to identify this suspicious behavior. So we already got our logs. We can just go down and then put in this straight slash. This straight slash is just telling Splunk, or this is an SPL query. You are probably writing an SPL query right now. So index employee. So this index employee is telling the Splunk that, okay, I want you to bring me all the logs from this particular index, and then source types will be CSV. Obviously, it will be CSV because the file we uploaded is a CSV file. But this is just a best practice, because even though I did not include this, it will give us same result because all the logs are actually CSV, right? So you can just, but the best practice is actually to include maybe authentication logs, or maybe you want firewall logs, or you want IDS logs or IPS logs. You can just specify that in this source type. But ours is not categorized like that. All these logs is CSV logs, so that's just a best practice. So after this straight line is actually telling Splunk that, okay, I'm done with the first line. That's basically what I want for the first line. So after you are done executing that, what I want you to do next is to give me all the successful and failed login attempts, right? So what we can do is no, let's quickly do this. So this is just like this is just like a keyword. Like you want to input a keyword so it can extract the keyword from this particular log. So the keyword is event ID. No, not even event ID. Yeah, let's see, events underscore ID. If you guys don't forget, did not forget, we said event ID 4624 is for failed login attempts, while no, sorry, successful login attempts. While event ID 4625 is for, sorry, yeah. So let me just quickly write a message from a colleague. Sorry. All right. So as I'm saying, event ID 4624 is for failed successful login attempt. Then event ID 4625 is for failed login attempts, right? So event underscore ID then equals 4624, right? 4624. So it's telling with anywhere you see this is like a keyword, right? What we want to extract, right? Or then it will be like, oh, we use this operator. Yeah, we call it operator in programming. And then all right. So sorry, a message just coming. And then you can just add another event. Sorry, so ID 4625. But before I even continue, let me quickly show you guys the magic or what this actually does. Sorry for that. A call just came in. I think I need to mute. Sorry for that. source type, description, destination port. We have event ID, event type, host name. We also have a host name, source IP. Yeah. So let's quickly use source count by source IP. Let's create a table. Sorry guys, this is the last thing we're going to be doing actually. This is the last thing because I'm going to be continuing. Table. Oh, why is it not working now? Here's a table. Let's see. Let's see. Wow. So this is basically all the source IPs, and then let's see. I don't know if you guys are understanding what I'm doing. Right. So first of all, we said index employee, right? Get the logs from the index employee. Then source type CSV, obviously, and event ID. This is basically like a keyword. Event ID 4624 means failed or successful logins, and event ID 4625 means it means or it's telling you that this is a failed login. Oh, sorry, failed login, right? So and this it gave us all the logs that has to do with successful and failed logins. You can see we have success and we have a failed login right here. So what we want to do right now is just to create a table in order to just we want to just complete this first stack. So complete this first stack so you can just I can just give you the rest as an assignment or class work so you guys can do it. Identify suspicious behavior in the log. So you just need to identify suspicious behavior, right? Event different source IP. Then source IP, we have this source IP field, this same IP field, this same IP field again, and so on and so forth. So sorry. So actually we have this IP field how many times? One, two, three, four. It's same IP address actually, if you notice. And we have another field IP address for 5, 6, and then 7, 8, 9, 10. Yeah, so 10 times. So this actually IP address failed 10 times. So obviously this malicious, right? Obviously this malicious. So what you can try to do is just to see okay which user was being affected. As you can see, you need to check which user was being affected. And just click on this. Okay, this is the host employee, source type CSV, description, backdoor account still active. So obviously this is even a backdoor account, right? This is the port 3389. I don't know. Let's quickly search that port 3389. So port 3389 the port TCP was used by Microsoft Remote Desktop. Sorry, we just even said RDP. I can't believe I forgot this and RDP, but so you can just check it up if you don't know what port what port number that is. So this means the attacker already have a backdoor using the remote desktop protocol to that particular system. So this is the log source protocol source IP. So this is the source IP. The attacker that's actually attacking us. We got the source IP, source port, the source status, success actually, and this is a success, right? The username, this is the username SPZ backup 2, and this is the time. You can check the time if it's not too far away. You can just maybe if it's something that happened recently, you can just simply quickly escalate this to the tier 3 SOC analyst or tier 2 SOC analyst to maybe isolate or block that particular IP address and isolate the affected system. So you guys should just finish this and also just complete this as your assignment. I'm going to also be sending you guys the log file and also more assignments you can do or like more stuff you can do using that particular log file. Maybe I did not show you more. So if you need anything, you can just reach out to me privately if you have any questions so we can quickly do that. Right. So thank you very much and sorry for your time. So I will not be asking for any questions. I know you guys have a question, just drop it in the group.
taking a lot of time already. There's going to be a review on the timing. I have a lot to teach you guys, but we have limited time, right? We are going to review that. So please, we beg that you don't, get angry because of the time. I know that you guys are learning a lot at the same time. And that was why we mentioned it right from the beginning that this is going to be a rigorous mentorship program because of the time crunch that we're experiencing, considering the fact that this is just a 1 month program. But there's no problem. So you guys should enjoy the rest of the night. We're going to talk again on Monday. So please do all the assignments assigned to you. Thank you so much and bye for now.